and 17 onwards, we also diverted our directions to a more productive and sustainable way. Based on 2016, 17 and 18 need analysis, we also identified, in addition to the long-term, short-term and medium-term programs, we should organize kind of workshops, webinar, and now it is seminar, and now it is webinar due to this COVID pandemic. Even I would mention you all in this year, 2021, we were planning to organize 5 workshops. I am happy to say this is the 5th one. The first one was GIS and GPS applications in plantation sector. Next one was quite related to this topic. It is forestry management in plantation sector. The third one was labor handling. And 4th one was artificial intelligence and its application in plantation industry. And this is the 5th one, energy management and conservation. Once we turn into the plantation sector, it is mainly, you all know very well, 3 crops: tea, rubber, and coconut, and other ancillary crops also. With the present situations, we have been empowered with the other plantation crops as well, like palmyra, cashew, sugarcane is also coming under the purview of plantation ministry. Once we talk about the plantation industry, even we can't forget the tea industry, which is, I would say, main sector of the plantation industry. We have 695 tea factories in operating, which are directly connected to the national grid. In addition to this electrical energy, some factories, they use their own peltons, these hydropower plants, and some use solar, and some are using still planning to go for wind energy. And most of, I would say, not actually tea factory, tea estates, they maintain very good of fuel wood and forestry system as well. Especially since tea sector is the major sector in the plantation industry, I will give some few figures related to the tea industry. As I told you, it is the major sector. We annually produce nearly 300 million kilograms of tea. For average electrical consumption is about 0.78 kilowatts per kg of made tea. That is in electrical consumption. And once we turn into the thermal energy, especially in fuel wood concern, it is 1.5 kg to 2 kg fuel wood to make for 1 kg of made tea. Then you all can imagine what is the energy requirement in the tea sector. Energy requirement in the tea sector. And on the other hand, we have some rubber factories and rubber estates and coconut mill and other processing centers, like even cinnamon and cashew, palmyra, so on and so forth. But in simply, you all can get an idea what is the energy requirement for the tea sector with these figures: 300 million kgs of tea, and the consumption is also just I mentioned what electrical consumption per kg of made tea and fuel wood. And whatever it might be this electrical or thermal energy, the energy can be saved in different levels. I think Dr. Harsh and other experts, especially Dr. Tilak and engineer Sanat Kitsiri, they are well conversant of these subjects. They will be explaining you all how in device level we can save energy can be saved than the system level. I think they will be delivering you, which is more important for this topic today. And I would say as an industry, plantation industry, we have, especially in tea sector, we have over 230,000 hectares of tea land and rubber and coconut land as well. Once we consider the entire plantation industry covering tea, coconut, rubber and all other ancillary crops, 30% of lands are underutilized or marginal. In plantation industry, especially in tea sector, you also at the red category or unproductive land or whatever it is, along with the other bare lands. 30% lands are, record says 30% lands are either underutilized or marginalized. So this land extent, we can convert it into full-wood plantations. I think I know very well that Dr. Harsha is so keen on forest plantations and especially full-wood management. I know well, he also contributed for a couple of national level projects as well, especially in the full-wood management under UN projects. In the Kenya, minimum 30% of full-wood land should be maintained compared with the total tea lands. 30% should be maintained. It is compulsory. It should be done. But in here, TRA recommendation is to maintain 10 to 15%. I know well, some plantations companies, they maintain over 15%, but some are still not. So we have to rethink of that. Then of course, we can be, you all can be, self-sufficient in full-wood plantations. From our end, as the National Education Service provides in the plantation sector, we will provide you the required knowledge, skills, and competency. That is our, I would say, responsibility and the accountability towards the plantation industry. In the especially thermal energy security concerns, we should practice, a couple of strategies, especially improvement of operating practices. That is very important. Operating practices should be further improved. And the second one is efficiency of our factories. I think either Dr. Harsho, Engineer Sanat Kitsiri, they will be delivering the presentations today, how we can improve the efficiency of your factories. That is also very important. And the diversifications of suppliers and the different species. You know that very well. In the plantation sector, we have a couple of forestry species which can be easily practiced with the high calorific value, like eucalyptus, either all eucalyptus species, Leandis, Microcontis, and red gum, whatever.
Thank you.
And the Caliandra, Acacia decorans, and Gliricidia also can be used as fuel. For this matter concern, we should rethink how we can diversify into different species, which would be benefited to maximize your fuel requirement and the efficiency. And the last one is, we should be self-sufficient in the fuel. Because since if we have land, if we have technology, if we have the required knowledge and the competency, of course, we have to go for the self-sufficiency. Then at least we can save our natural forests, especially the people who are, I know that very well, just I went through the participants list, all you all are senior planters and well-experienced planters. You all know very well how some full-woods are coming to our states. That is very important, not as the planters, as citizen of the country, we should rethink of this. To be self-sufficient in the full-wood, it will be a kind of service to the country, especially in conserving our environment. I'm not going to speak furthermore because I would have to attend for another webinar. So I wish you all for a very productive workshop today. Once again, I'm welcoming all these speakers and participants from different plantations, companies and factories, and different representing different organizations. And I also would like to welcome our head of academic affairs and the coordinator of this program, Vidura Bandara. Thank you very much. I wish you all for a very productive workshop. Thank you very much once again.
Thank you very much, sir. That was a kind brief and very brief introductions about the industry and the policy matters, as well as how we can save the energy. So as for the moving to the our sessions, so first lecture will be delivered by Engineer Harsha Vikramasinghe under the topic of energy policy codes, standard and energy usage benchmark regulations. So he engineer Harsha Vikramasinghe, he's a chartered mechanical engineer by profession, graduated from the University of Moratuwa, and he has another MBA from the University of Colombo. His focus area is energy policy, energy efficiency, renewable energy development, project financing, operation efficiency of industry and processes. He has achieved so many things to the country as well as to these sectors. Drafting the national energy policy, key contributors to the design of the code-based technology-specific tariff regimes for the renewables, as well as one support was to introduce net metering concept to enhance of the same to the net accounting and net plus schemes, as well as one of the architects of the Sri Lankan Sustainable Energy Authority. So his roles as a national project director of the UNDP NAMA project, as well as some projects delivered with the Sustainable Energy Authority. So then over to you, Mr. Harsha Vikramasinghe, to deliver this lecture on the topic of energy policy codes, standard and energy usage and benchmark regulation to the audience. Over to you. Thank you very much.
Thank you, Mr. Vidura Bandara, for the kind introduction, and a very good morning to all of you. Senior planters, I'm told you are here from many different areas of the country. And the kind words of Dr. Prasad Dharmasena, I must correct him. He made a reference to me as Dr. Harsha. I am not a doctor, but a plain Mr. So just to make that correction, important correction. So today I have developed a presentation touching on the national energy policy, then some codes and standards, things happening elsewhere, not very much related to the plantation sector of the country. But the last item, the energy usage benchmark regulation, is a serious matter. All the planters, the plantation managers in the country, you have to take very serious note of, because it is not going to impact you immediately, but it is going to impact you in the not so distant future. So let me take you through the presentations. But before that, there are some things I would like to echo what Dr. Dharmas had told you about fuel load calculation, because I have not included that in my presentation. It is a God-given opportunity for the plantation companies to make use of the unproductive land for timber crops, as well as fuel load crops if it is permitted by the leasehold you have got, because land is a very serious shortage in our country, and fuel wood appears to be the savior in many respects. One thing, the planet threatening carbon dioxide emissions from energy facilities, we have to capture as much as possible this carbon dioxide and have it in the solid state in the timber and wood. So we will have a carbon sinking operation in your plantations. Similarly, being self-sufficient and even becoming producers of fuel wood is going to be a lucrative income source for the plantations in years to come, because there is a very large demand we have developed from the export processing zones in the country. For example, the Biagama export processing zone alone is consuming approximately 500 to 1,000 tons of fuel wood every day. So there is a huge demand, and the prices are not very low. So the suppliers can benefit if you have a good recyclable plantation where fuel wood can be grown. It is very much in your favor as an additional income source, and also the carbon benefits. So we are in the process of drafting a regulation where biomass energy development areas can be seen as a different item in the plantation sector, where it will help the energy security of the country, as well as the balance sheet of the plantation company. So we will work together with agencies like NIPM. So we will definitely benefit the country and the planet as a whole. So now back to the presentation. Uh, my presentation outline says national energy policy and strategies, and then the standards and codes, and the energy usage benchmark regulations. Let me take you to the learning outcomes. After following my presentation, you will get an introduction to the national energy policy and strategies of the country, especially with the view of there are several elements in this national policy, but on the energy efficiency side, special emphasis. Then an introduction to the different codes and standards used in ranking of buildings. Not very much relevant to the plantation community, I must say, but you might be interested in understanding these things. And ramifications of the energy usage benchmark regulation on energy reporting, auditing, and improvement of energy performance of the facilities you manage. So that is the most important part of my lecture today. So before starting the presentation proper, why worry about anything? So we can be very happily do without worrying about anything, but we worry about many things. As you well aware, we worry about our children, we worry about our country, and there are so many. And we have to, as managers, we have to worry about our businesses, so the production facilities we manage. So why worry about things is a pertinent thing. So we will just focus on energy. Why are we worried about energy? So firstly, if something is to be improved, we have to control it. So this is a very important slide I am presenting to you. If something is to be improved, we have to control it. Otherwise, we have no control over it. Then if something is to be controlled, you have to understand it. So that is the second part of the problem about worrying. So if we need to control it, we have to understand the phenomena, whatever it is. And if something is to be understood, we have to measure it. And if the things are to be sustained, we have to provide feedback to the people who are doing all these things. So energy efficiency improvement starts here. So it is we are going to improve the energy efficiency of your facilities. So the amount of electricity consumed in making a kilogram of black tea or making a kilogram of desiccated coconut or rubber is very well known. Dr. Prasad Dharmasena mentioned it, and the amount of fuel wood consumed in making these commodities again very well known. So if we can do anything to reduce these quantities, we have a winning formula. So remember these 4 points. If something is to be improved, you have to control it. And if something is to be controlled, you have to understand it. And if something is to be understood, you have to measure it. If the things is to be sustained, you have to provide feedback. Just put this in the item of raising a family, your own children. So we all require our children to be better performing students, or for them to do well in their lives. So if we are to improve the lot of our children, we have to exert some kind of control. Just letting them grow won't help. And if we have to control our children, we have to understand them properly. So child psychology is the difficult thing, but simply understand their feelings and how they are progressing or not progressing. These things matter. And if to be understood, the academic performance or whatever the performance, we have to measure it. That is why every end of the term, we get a report card to the parents. So after seeing the report card, if we keep silent without either praising them or providing feedback to the student or the child, then we have not completed the management cycle. This is why age-old systems depend on these things. You have to always improve certain things, and you have to control it, you have to understand it, and you have to sustain these processes. Just remember, for any situation, it can be the cash management, it can be the fertilizer management, energy management, whatever. If there's any resource going into your production, just keep this slide in your mind. This is a very important slide, actually the most important slide of my presentation today. So we move on. So energy management is about good metering and measurements. I'm sure Dr. Siamala Pitia is the best person to educate you on this, but I'm just making a casual remark. And good record keeping and energy accounting is a must. So I hats off to the plantation community. I think your industry is the place where we learn many things about record keeping, starting from the tea book and the production data, the labor check rolls, everything. It is such a nicely kept system of input accounting I have ever seen anywhere in the world. So hats off to you. Keep these practices going on, but we can improve it to the improve the energy efficiency part as well. So good record keeping and energy accounting is the key here in energy efficiency improvement. And employee and customer education. If we are taking decisions and if we are keeping our people, the operatives who are doing the energy related tasks in your factory in the dark, then it doesn't solve any problem. So we have to always educate our employees and customers. And mind you, this has to be a continuous and frequent exercise. You just can't do an annual exercise and forget about it. At least we recommend to have a monthly meeting on energy. If failing which, at least a quarterly meeting, stock taking, and I mean refer to what happened the previous year and how you are doing right now. These things will be dealt with extensively by Dr. Tilak Simala PTA. But let me remind you. So, and incentives to staff and lower the lower price to customers. These things can be provided if your factory is really doing good energy efficiency improvement things. And institutionalizing the energy management is like the ISO 14,000, ISO 9,000. Some of you may have gone through the full cycle. So you have to institutionalize the energy management practices as well. And there are ways you can do it. Let us discuss that during the codes and practices session. And how energy management can help. It's a culture of measuring and monitoring. I don't have to teach the planters how to maintain a good culture, because this is one of the best places I have ever seen in maintaining a measurement culture. In other industries, you will be surprised to understand you can't even find the previous year's records on certain other production facilities we are serving. So in that respect, even for the rainfall measurements, we bank on the plantation community. We have such a good record of rainfall in our country because thanks to the planters from the bygone era. And the culture of measuring and monitoring can have a deep impact on other resources as well. So if the energy management brings in a culture of measurement and monitoring, automatically the fertilizer, labor inputs, all other things also will get measured and controlled. So that is the important part. So reducing waste start here, burden on the process finances and burden on the environment. So waste reduction can come in because you are closely monitoring what is happening down there. I hope I'm making it very clear and you can hear me well.
Thank you.
If you have any problem, just raise your hand. I will attend to those problems. And forcing a long-term strategic focus on your system rather than short-term firefighting is the way to go. Otherwise, people always resist that kind of abrupt changes in your practices. So the once introduced, the life cycle, LCC stand for life cycle cost. So if you successfully implement energy management practices in the factory, definitely the life cycle cost thinking will come into your staff, and they will think twice before purchasing anything which will have greater significance in the time during the operations rather than during the purchase. So that's a added benefit of these things. So that being said, let us move on with the national energy policy. Any problem or any question up to this point? I can conduct this in a very interactive manner. If you have anything, just unmute and speak. You can speak up. Okay, in the absence of any questions, we will move on. So, contrary to popular belief, we have a policy for the national energy affairs. Unlike many other sectors, I'm quite sure the agricultural policy of this country is in the draft form for the last 20 years, if I'm not mistaken. It never materialized as a published national policy. Correct me if I'm wrong, but I just don't know whether we have a national policy on the plantations. I am quite sure we don't have a national health policy, or many other policies are missing in our country. That is why our country is in this sorry situation. So we don't have long-term policies, but very fortunately, we were able to put together the national energy policy after a very prolonged battle with so many stakeholders. We managed to finally get it across to the parliament on the 23rd of August 2019. And fortunately, now we have an energy policy for our country for the ensuing 5 years, which is and up to 2025, we have this policy in place. So that's the better part. And this policy has 10 pillars, 10 major pillars. Let me quickly show you what these are. So, assuring energy security, providing access to energy services, providing energy services to the optimal cost to the national economy. Like that, there are several policies. My focus today is the fourth pillar, which is improving energy efficiency and conservation. I will briefly explain you what these things are about. So, assuring energy security is concerning the energy security of the country, meaning where we purchase oil, where we purchase coal, external dealings such as that, and also enhancing our own energy supply in the country, like solar, wind, hydropower, developing our own resources like even biomass, fuel wood. These things are covered in the first bullet, the assuring energy security. So the people, the poor man in the rural or the remote location of the country, providing him an electricity connection, failing which providing him kerosene for his lighting needs and the fuel to cook his meals. All these things are dealt with under the energy security pillar of the energy policy. Then providing access to energy services, again, the energy services such as petroleum, that is transport fuel, and grid electricity, provision to all corners of the country are dealt with in the item 2. So we are fortunate to have reached full electrification of a country, which is not even achievable in some of the developed European countries. And not everyone is getting grid electricity, but in our country, except for the 30,000 people, the new constructions, as well as some remote locations, everyone else in our country, all 6.2 million households, they collectively get electricity. So that's a major win for the country. And but petroleum from the remote plantations, you know, there are unauthorized vendors who are selling petrol and diesel in the village boutiques because the petroleum corporation is not yet serving this area. So that is the kind of things we deal with in the policy number 2, the element number 2, the access to energy services. Then providing energy services at the optimum cost to the national economy is about how we purchase our coal, how we purchase our petroleum fuels, and how we purchase renewable energy from the private sector. All that is will have to be done at cost competitive, price competitive level. So ensuring the least cost energy comes to the people and the businesses is dealt with in the bullet number 3. We skip bullet number 4 because we are going to deal extensively with that. Then enhancing self-reliance is about developing our own energy. That is why in my introduction, I gave you the importance of fuel wood cultivation in the unused plots of plantation land in the country. Then caring for the environment from energy-related emissions of carbon dioxide and other gases. Also, and also operation of our power plants, how it can deeply impact other environmental systems. We take care of that. So that is there with in the pillar number 6, the caring for the environment. And enhancing the share of renewable energy, there is a very prominent item, as you all of you may have heard. We are in the drive to secure 70% grid electricity generation by 2030. It's a very difficult and challenging task given to us by His Excellency the President. And then strengthening the good governance in the energy sector, the way we transact with other agencies, foreign governments, and our own customers, how good governance can help in our day-to-day operations is dealt in pillar number 8. And securing land for future energy infrastructure is a very important one, because some of you may be aware, it's the most difficult and challenging task to find land for anything in our country. So that is why we have to make the full use of all the land. If the plantation companies are sitting on 1/3 of their land doing nothing, it's a national crime. So that is why we would like to engage with you to get this land back into some kind of productive engagement. So we will gain something out of this. At least if we don't gain fuel wood, we could have fixed the atmosphere partially by absorbing carbon dioxide. So let us think about this. So securing land for future energy infrastructure, not only for electricity power generation facilities, but also for harbor facilities, mooring facilities, and corridors for pipeline transport, as well as power lines. Securing these land resources, we have taken care of in the pillar number 9. And the final pillar, providing opportunities for innovation and entrepreneurship. Because our energy sector is so huge, we thought of giving the local entrepreneurs and manufacturers to make things and design things, systems, processes, and products, services, whatever that is there, to earn and do business with the sale of energy and other related transactions. So these things are covered in the National Energy Policy, which will be in effect till 2025. So it has 10 pillars, 95 strategic interventions, and 75 key results. So we will not deal with all these things. It's a lecture in itself, so it will take 3-4 hours for me to cover this. But we will concentrate on the energy management part, which is the 4th pillar, energy efficiency. So there will be these are the strategic interventions we have proposed. So there will be a national program on energy efficiency improvement and conservation. So stakeholders in household, industrial, and commercial sector. So you fall under industrial sector, even though it's an agricultural enterprise. So improving your energy efficiency is covered in the national program. And for the home household sector, the residential sector, the labeling of appliances and introducing green procurement process in the state and private sector organizations. So whenever you have a energy using equipment purchase in your organizations, you can always contact us and get our services, our partnership to minimize the life cycle cost of your purchase. So if you are purchasing a motor, maybe say 10 horsepower motor for your the manufacturing operation, there can be a cheaper inefficient motor and an expensive but efficient motor both in the market. Say one is selling at say 35,000 rupees, the other one may be selling at 50,000. But if you do a life cycle cost evaluation, and if your motor happens to run for say 12 hours a day every day, then you might find that 50,000 motor is actually delivering more value to your organization than the cheap 35,000 motor. You may be saving 15,000 rupees in the purchase decision, but if you do perform a life cycle cost analysis, the green procurement way, you will find out you will spend a couple of millions more than the 35,000 motor during the use of that motor. So this kind of life cycle cost analysis and things we have mastered, and we are there to help you. If ever you need that kind of help, just contact our industrial division, which is run by Mr. Sanath Kitsiri, who will be doing the third presentation today. So we are there to help you in drafting the specifications and even in tender evaluation. So just a phone call away, we can help you. And a home productivity improvement program for the to empower women and the people who are running the home finances. There will be another program, and taxation and other incentives and disincentives to support the market for efficient technology. So this 35,000 motor and the 50,000 motor, we are trying to change the equation by taxing more inefficient products and giving tax concessions to efficient products. That way, the market for efficient products will increase. And provide expert energy advisory services to state and private sector service providers to provide energy efficiency. So if you have not done a decent energy audit in your facility, just contact us. We can get someone who will do that for a fee, which is we recommend you conduct an energy audit in your facilities at least every 2 years, because things tend to deteriorate when we move on. So these are the things, and there are some more. And water resources will be recognized as a valuable indigenous energy resource. So this is not very much relevant to today's discussion. That is power generation water and agricultural water. So it will be treated as a valuable energy commodity. And conversion efficiency of power generation facilities, again, not relevant to our discussion, but this for the CEB and private sector generators. Then a strategic plan for street lighting to convert all the street lamps in the country, to LEDs. So we will have smaller load to deal with. And automated demand response technologies will be considered as a main demand side management strategy. So this is a new item. I will explain it a bit. So in your facility, in your factory, you can demarcate the essential loads and the non-essential loads. So as you are very much aware, the energy usage during the peak hours, that is 6:30 in the evening till 10:30 in the night, that band provides you very expensive energy. So if you can defer part of your manufacturing away from that high peak power period, that will be a cost saving for the factory. I'm sure most of you are doing that. The shifting room operations and all that you can skip during this expensive period. But the automated demand response is a way to automate this process, where you demarcate part of your factory as a sacrificial load and part of your factory as essential load. So if there is a need to cut down the electricity demand from the demand side, the customer side, the utility will gain control over your sacrificial load at the factory. Meaning, if you are, for example, we can say the shifting room you have given as a sacrificial load to the utility. So it has a control circuit and a internet connected device, where the remotely the Ceylon Electricity Board power plant operators can switch off your shifting room when there is a surge in demand for some other thing. So because you have termed it as a non-essential load, even if you have been working there, the power will go for that particular part of the factory, and you can reschedule that manufacturing operation. But by doing that, you will be earning some additional money. So this system is not yet available in our country, but we are proposing. So if you are sacrificing your demand for the sake of some other customer, you will be paid for that sacrificed demand. So that is happening in some part of the world. It's a very new concept. So we are planning to introduce it to Sri Lanka, and I would like to hear from you whether this sounds a good idea or not. So the other items in the this fourth element, virtual offices and video conferencing will be, that is exactly what we are doing. So need to travel and need to waste office space will be cut down to the minimum. Thanks to the pandemic, we have almost realized all our objectives under this element. And transport energy will be developed to avoid shift and improve. I must say the boat leaf industry is a very serious culprit in this thing, because I have seen Balangoda lorries coming to faraway places in Ratnapura, and Ratnapura lorries looking for green leaf in Balangoda. So I just don't understand the logic of this. So how these things happen, but we tend to waste a lot of transport energy in this boat leaf business. I just can't comprehend how this happened. So by avoiding unnecessary transport of green leaf tea or whatever, it is always better to transport finished goods than raw material. Always keep that in mind. So that way we will reduce our cost and the emission. Then economic activities will be developed to dense clusters. So this related to urban development and things, we will skip that. And sustainable neighborhoods are also developing not only home plots, but developing an area just like a neighborhood. So that is again going to save a lot of energy. And energy efficiency will be a primary concern in retrofits, and new building designs will be evaluated for their energy performance on mandatory basis. So energy efficiency building code will be a mandatory one. So even if you are building a new facility, new tea factory, you might have to consult us in future. And smart technologies, including smart buildings, uh, smart metering, and where price signals are provided directly to the customers will be introduced. So these are the demand management strategies. And fuel efficiency of the vehicles will be uh, a key consideration in applicable taxes. So we are not yet there, but if your vehicle is fuel guzzling V8 Land Cruiser, you will be taxed more. And if it is a very efficient, say, double cab, you will be taxed less. That is what we intend to introduce. So these are the elements we have dealt with in the national energy policy. So any questions up to this point?
Yes, Mr. Harsha, there is a one question in the chat box.
Yes.
Can move your attention to that one as well.
Yes, I have seen the chat book. The Department of Forest Conservation has informed us that we have decided not to cultivate eucalyptus. So without eucalyptus, how can we manage the foliage requirement? That must be the question. So in that case, the Forest Department will have to tell us what are the species they will allow. There are not only eucalyptus, but there are whole heap of other species. Actually, we have identified 12 species good for different agroecological zones of the country, like acacia, cassia. There are so many varieties. So if the forest department is in agreement, they will allow you to use the other species as well. So let us consult them and see. It's not proper for me to speak on behalf of the forest department, but we have colleagues working in that department. We will let you know what these things are about. So that is the energy policy, briefly the energy policy for you. And I will now quickly go through the modes of practices available in the world and what is going to happen in Sri Lanka. So I just this is not very much relevant to the plantation community, but let me take you through those. So there are several systems applicable in the country for the moment. Uh, the lead system is coming from the United States of America, where the Green Building Council of that country, a non-profit organization, they started this process in 1993 as a knowledge provider, just like the NIPM. They provide knowledge to the construction industry and a thought leader. So it was a response to the aging building stock of the the North American continent. So they wanted to do something about the dilapidated old buildings. So they devised a system where the building energy efficiency can be improved by doing certain things. So it is operating with the 9 elements, the 9 integrated systems allowing buildings to earn a ranking. So the 9 elements are the location and transportation. So if it is in a very easily accessible place, you get more points. But if it is a godforsaken remote location, you get lesser points. Like and sustainable sites. So if the sites are in a pristine greenfield level, you get lesser points. But if it's already in a developable area, previously used location, you get more points. And using the water efficiently gets you some points. And energy and atmosphere is the place where we working. So amount of emissions done by your building during the life cycle of the building and the amount of energy used will earn you certain points. And the material and resources you are using, whether these are locally available materials, you have to transport these great distances, or whether making these materials cause a lot of greenhouse gases and things are mentioned here. And the maintenance of indoor environmental quality, how fresh air is brought in, how healthy this environment, things like that are captured here. And amount of innovation used in your building design is rewarded here. And regional priority, this is not very much relevant to our small country, but for America, it is very much relevant. If you are sourcing material from the far corner of America and using it in the other corner, then you get lower points. But if you are using regionally sourced materials, then you are gaining more points, right? Then integrated process, whether you have done everything together, that earns you points like that. There is a point scheme up to 99, if I'm not mistaken. So based on the point scheme, you get either a certified rating, silver, gold, or platinum. There are 4 levels. So you tend to if your building is really inclined in the green facility, as a designed as a green facility, you might earn a platinum status. I know there is at least one apparel manufacturer in the country who has reached the platinum status in one of their facilities in Seedua. So there are large number of silver and gold rated buildings in the country. So this is a good system to keep the energy burden and the environmental burden low in your buildings. So there are many abbreviations used in this industry. LEED stands for leadership in environmental, whatever, I just can't remember it. Leadership in energy, environment, design, or something like that. So LEED AP, LEED AB, NC, CS, CI, like that. There are so many abbreviations associated with this LEED certification system. But there are serious criticisms of this thing by other courts, saying that this is allowing people to score very easy points and become a green facility even without doing anything actually green about that building. So with that criticism, but still people are using, because it's a very well structured and easy to achieve system. So the LEED processes, there are so many processes associated with the design. So LEED AP, the accredited professional. So he gets some formal training and can undertake specific tasks under the LEED system. And EB stands for existing building. So if you are doing a retrofit and arrive at 8% savings, you are getting 1 point. If you are achieving 26% or more, 10 points. 44% savings, 19 points, like that. You can get your building retrofitted building also rated. So if it's a new building, then the LEED system will compare the energy records of a comparable building, reference building, and compare it with your new building. And if you have saved 12%, you get 1 point, 30%, 10 points, and 40 saving, you get 19 points. Like that, it is there. And the CS and CI is for common facilities like the World Trade Center building, where the core and shell is the outer envelope, and the air conditioning and large facilities of that building operated by the building owner himself. The CS refers to core and shell, is that part of the thing. But if you have an office there in the World Trade Center, that applies to the second part, LEED CI, or the common interiors, where the changing of light bulbs, the office equipment, and all that, which is under the control of the tenant. So the first one, core and shell, is the landlord's responsibility. Common interiors is the tenant's responsibility. So again, you can earn 14 points and 37 points respectively, even if you are living in a rented out, leased out building. And similarly, even if you are a major building owner, you can also do certain things to increase the green credentials of the particular thing. So that's being said about the lead certification system. I'm almost running out of time. So green mark of BCA is Building Construction Authority of Singapore. They introduced this in 2005. So it is a code we rely very much on because it is substantially similar to Sri Lanka, the environmental condition. So we can bank on the BCA system, green mark, and it is again based on 16 criteria, 52 indicators and 140 point system. So smart and healthy building, climate responsive, resource stewardship, building energy performance, and advanced green efforts are the key areas. So in the diagram, it is shown like this: the 5 elements I mentioned and the 16 other things right around. So based on this, you can earn the BCA green mark. And the beauty of the Singaporean system is they make it stringent by the year. Every year there is a revision, so it becomes more stringent and stringent. So people will have to take a lot of measures to make their building stock energy efficient. And then we have the ASHRAE 90.1, which is the uh, Air Conditioning and Refrigeration Engineers Association again in the United States. So it has a separate volume called 90.1. It's not very much relevant to you. It's for the commercial buildings, air conditioned buildings. So I will just explain you briefly. This is a very technically sound and implemented thing compared to the lead system and the green mark of Singapore. This is a very sturdy and useful and result-driven code. So we tend to bank our building code very much on the ASHRAE 90.1 as a result. So it covers the building envelope, the outer shell of the building, air conditioning and ventilation system, lighting system, service water heating, and the other equipment in the building. So these things are covered in the 90.1, and our building code also is structured very much in. Yeah, so these things I will skip because it is somewhat similar to the green building system. So the intended design and the comparable building is compared, and you have to the design energy cost must be always lower than the energy cost budget of the particular building. So they are driven to pluck the low hanging fruits first. I mean the easier things first, and progress to the difficult things. That is how these things are done in the case of ASHRAE building code. So there is a extensive user manual, and this is not very much relevant to you. I will skip this slide. And then it comes to the government effort. The United States government, you may have seen this logo in your computer monitors, Energy Star labeling. So based on the same energy label, appliance energy labeling program, they have the Environmental Protection Agency of the USA. They have introduced a building energy system on voluntary basis since 1991, but very unfortunately, it's a difficult code to follow. As a result, people are following lead the private sector initiative more than the government sector initiative in America. But it's nevertheless a good code. Then this is important for the industry and the rubber industry, also the industry, because ISO 5000 and 9000, most of you are very much aware how these systems work. And we are glad to say there is already a system for energy management, ISO 50001. So it was launched in 2011 and underwent a major revision in 2018. So there are no benchmarks, but you just like the quality management system, it's built on your own processes and own targets. So continuous improvement system based on the PDCA cycle. I'm sure you understand what PDCA cycle, the Japanese way of management. So development of policies, setting targets and objectives, and making data-backed decisions, and measuring results, and review effectiveness and continuation of the improvement cycle. So this is how ISO 5001 system works. And fortunately, our Sri Lanka Standard Institution, they are an accredited body who will help you in implementing ISO 5001. If you are really keen, contact us. We can get you help to do these things in your factory. And it's based on a family of documents on this fashion: energy audits, energy management systems, guidance, like that. So yeah, if you are conversant with 9001 and 14001, this is the ideal solution, a complete solution for you to consider. And any questions up to this point? Okay. In the absence of any questions, we will move on. The difficult part, but I have very limited time. But let me try to conclude it as fast as I can. Energy benchmark regulation is not readily applicable to your organization yet, but the second batch of agencies will definitely cover the plantations. So be careful, try to fully understand what this is about. So some of you may be very much aware of the legal system of our country, but for the people who are not very much aware of the legal system, let me take you through quickly. We at the apex level, we have the constitution of our country, then the acts of parliament. Sri Lanka Sustainable Energy Authority Act number 35 of 2007 is one such act. And the act establishing the National Institute of Plantation Management in 1979 also is at the same level. It's a parliamentary act. Then coming as offspring of these acts, there are subsidiary legislations or regulations. We call them regulations. We can devise certain other laws out of these provisions in the act, and these becomes regulations. So we are going to use the provisions in the section 36 of our act to make a new regulation or a new law for the country for to manage energy in certain facilities. And then there is a lesser piece of legislation known as orders and rules, which can be made by the minister without going through the full cycle of the subsidy legislation like a regulation. Then we have standard practices, which there's no written law governing these things, but because we have done it for so many years, these things become practices and also become part of the legal system of the country. So based on this, we have devised the new regulation. So let me quickly show you what are the provisions. The section 35, 36, these are the things which we used to develop the new regulation. And 37, 38, people who are engaged in this activity, all these these people can be empowered with the simple regulation. That is what we have done. And also covering 39 and 42 about energy information. What kind of information we can expect from a end user facility, and what will happen to the end user if we contravene this law. There are things which we can frame, which we have done effectively. So if we cover all the legal powers we have used the Sustainable Energy Authority Act number 35 of 2007 as foundation. Then the benchmark regulation, which I intend to explain here as the main framework, and schedules 1, 2, and 3 to demarcate who shall comply, and accreditation, who is empowered to do certain things, and rules on forced implementation. So all these things in combination we have given us this system, and the whole system is based on the ISIC information management system. ISIC stands for Industrial International Standard Industry Classification. There is a 4-digit system where all the manufacturing operations, service operations, business operations of any economy can be classified. So we have used this numbering system from the United Nations to classify industries. And when all these things happen together, we'll have a mandatory energy efficiency improvement and conservation program for the country. So the structure of the regulation is it's a self-nurturing scheme. we will force data out of the people. That is why I explained to you the importance of data, the measurement, and all that. So data acquisition and support and ever evolving your database. So year after year, just like your good old ebook, we will have large number of the 695 tea factories will be reporting to us, and we will get a very voluminous database on operations of each geographical region, agroecological region, and all the tea industry statistics will be available in a single place with regard to energy. And the benchmarks will be coagulated for different end-use categories. For example, low-country manufacture versus up-country manufacturing, there will be two different benchmarks because these processes are so different. So larger the number of points we have, the better developed benchmarks we can have. So maybe even the low country for the down south, deep down south, Akurasa, we can have a different set compared to Ratnapura. Like that, we will have different calculations for different data sets. And we will be immediately able to identify the underperforming facilities, and they will be requested to do energy audits and submit a plan of action of energy efficiency improvement and conservation. Remember this term EEINC stands for energy efficiency improvement and conservation. And if there are no improvements in the performance, then the user will be fined. We have proposed a 10% surcharge on annual energy expenditure, and it's still under discussion with the Department of Legal Draftsman of the constitutionality of this fine, but it will be a hefty fine. I am very much sure people will comply when they see this. Then published outputs, there will be the top 10 performing facilities in the category. So we will be naming the best performing 10 tea factories in the country and a congratulatory message in the local newspapers, and we will be star rated. So there will be 5-star tea facilities, 4-star like that, and also there will be a blacklist or kind of a list of bad people who are not complying with the energy benchmark also published. So this is how the regulation is going to work. So there's the stick and also the carrot. There will be fines and the shaming and the naming and shaming part of it. So no superintendent will like to see their factory in the blacklist. So they will strive hard to get their facilities in the compliance range. So they will definitely they will do it next year at least, improve their facilities to get out of the blacklist. That is our intervention. Yeah, sorry. So there are several definitions. I will just touch on the first one. The facility will be the energy using entity. In the case of tea factories, it's a simple factory producing a certain product like a tea factory or a desiccated coconut factory or a rubber factory. But there are other categories like large scale banks. Say, for example, if we take Hatton National Bank, they will have 100 plus branches right around the country, and they as a whole unit will come under the regulation. Even though the branch facility is a very small office, collectively they exert a lot of energy demand on the country. That's why we have taken them under our regulation. And also condominiums, individual homes like yours and mine, the planters bungalows will never come into this picture, but place like Trillium residencies where large number of housing units are grouped together in a condominium, they will come under this regulation very soon. So we have structured it like that. So you don't have to worry too much whether you are going to jail or you are going to pay the fine. If it's a factory producing a certain product, it will be the board of directors owning that facility. But if you are the sole proprietor, definitely it's you. So you have to be careful because the litigation and the consequences, everything rests on the board of directors, not the factory officer, not the mechanic, not the superintendent, not the Sinnadure, but the board of directors of that regional plantation company will be at fault. So we will be suing them. So the effect will be very severe on the culprit plantation managers. So beware. So there are certain things I have to explain here. So there is a particular person known as the facility manager, in which case it becomes the superintendent of your organization. In the case of the energy manager, it will be the most likely the group engineer taking care of your energy expenditure of the tea factories coming under your purview. If it's a single factory, then probably you have to have at least an external energy manager to take care of your facility, like the fourth bullet here, a hired person or a firm for smaller facilities where no internal capacity is available. So if it's a very large facility and if your group engineer is fully if the group engineering manager is fully uh, occupied, then they can hire a firm to take care of their energy aspect of the facility. So this person or the entity will be responsible for energy data recording, reporting, and coordination with the authority. So you have to have an energy manager for your facility. Then there will be an energy auditor and an energy service provider. This is if your facility is found to be performing lesser than the lower than the energy benchmark, you will be required to conduct an energy audit immediately, and the energy auditor will have to give you a list of improvements possible for you to qualify. So if it is energy efficiency improvement, it will be known as the company will be known as the energy service company. If it is a company integrating solar into your rooftop, something like that, then it will be known as a RESCO, Renewable Energy Service Company. So you will have to get the services of such a company. So energy auditor, there are about 30 accredited energy auditors in our country. You can get the services of any one of them. So the implementation of this regulation, our authority, Sustainable Energy Authority, will identify a category or several categories of facilities and schedule those. So we can categorize office buildings used for only for during daytime, and we can also have several categories, all commercial buildings like that. Once a facility or a range of facilities are scheduled, then compliance is expected from these people. So there will be a report titled, the first report, the reported energy use. It will be the commissioning report of the new building or a derived from existing facilities, actual energy use for a particular period of time. We have taken the period to be 1 year. So starting from 2021, there will be the first data collection cycle where we will get the reported energy use from all the scheduled facilities at the tail end of year 2022. That is next year. So that is the first report we will be worried about. Then after collecting such data from several similar facilities, we will establish a benchmark. So collation of all this information, and we will establish a benchmark, like I said, one for the low country, one for the up country, like that. And we have done this for 14 sectors, but it is very much outdated. So the compliance, non-compliance will be evaluated after the lapse of the first year, which is 2022. And if you have achieved more than the energy productivity more than the benchmark, will be given a letter of commendation with technical help for further improvement from our authority. Thereafter, non-compliance, they will be required to perform an energy audit and provide a new report known as the prevalent energy use report. So it will also have the plan of action for improvement and implementation program, which year you are going to implement the rough fan modification, which year you are going to improve the T rollers, like that. There will be a energy efficiency improvement and conservation plan developed by you with the help of the accredited energy auditor. And after implementing this plan, you will most likely enter the whitelist or the compliance stream. So if you are still unable to comply with this requirement, then non-submission of information, but that is one offense. Failure to conduct the energy audit when requested, and failure to reduce energy use to the benchmark level. All these things will be taken as offenses, and there will be severe consequences. So just remember that. And there are 3 schedules. I will not take you much of your time. These regulations are one thing. Schedules attached to these things are a different thing, because these things are easy to change rather than changing the regulation. I will not take your time. So for the moment, we have schedules, buildings which are more than 5,000 square meters in size, and they are particular economic category. I will show you how. Then the Schedule 2 is the data submission formats, what to be filled. It is available in our website, so all the building owners can submit this energy data. And the Schedule 3 is a simple rating table, which will guide you to see what kind of star performance you have achieved, or whether you have entered the non-compliance rating level, whether you are below the benchmark or above. If above, how better you have performed against the others, it will be given in the Schedule 3. So with these schedules and the regulation, we are going to regulate. The good news is that coconut and rubber, they are not in the first item. For the first item, we have selected retail sale in non-specialized stores with food, beverage, and tobacco predominating, meaning places like Cargill's, Keel's, Apico, the food, the supermarket store we call. These are regulated in the first regulation, which will be effective from early next year. And the next item we have selected is the other retail sale of non-specialized stores. So there are 2 categories, but predominantly places like Keel's and Cargill's. Then we have selected the second class, that is the banking or the financial services industry, covering from the central banking industry, the central bank of our country, there's only one. Then other monetary intermediation, all the banks, leasing companies, except insurance companies and pension funds. So all the insurance companies and the EPF, ETF, those places are spared, but every other player in the financing community, they are taken care of under these things. So this is the 4-digit number I mentioned to you in the ISIC International Standard Industry Classification is the larger name, so the longer name. So there are 4-digit classification. We have taken 4711, 4719, and these numbers in the Schedule 1. So only these 2 sectors will be regulated in the coming year. But be careful, 2023, it is going to be the tea industry next. So we are quite keen to have all the 3 plantation communities under the same category in 2023. So you have to be prepared with the data submission, the appointment of energy managers, selection of energy auditors, all these things you will have to be prepared during the next year. We will keep you informed on what to do. So there you can identify your category here. I think the industry falls under food and beverages. I just don't remember the item. There's some number here. So your category and your 4-digit number can be selected from that one, and it will be regulated. So this is the way things are. The food industry division 10. So your thing is coming under most probably 10 and some other number. We will see that later. So the compliance, the commercial energy inputs can be easily accounted for. So electricity, diesel, fuel load, all that can be taken in. But if you are using your own fuel wood and own biogas generation at site and own solar generation from your rooftop, then there can be issues in data inputs. But the amount of output, it's very easy in the case of plantation processing, because kilogram of black tea is going to be your primary output, or desiccated coconut or the rubber kilograms. So it is very much easier for plantation community, but it's a nightmare for the banking community or the supermarket community to think about their output, what will be the output. So we are thinking hard these days how to capture it. And capturing all variables in the energy demand equation is essential. And data submissions must be able to complete their report generation uh, as given in schedule 2. So the offenses I mentioned to you, the failure to submit the reported energy use report, and failure to conduct the energy audit, and failure to reduce the specific energy use to below the benchmark. So all these things are offenses, and the consequences, fine, we have the fine stated in that is 100,000 rupees and 2 years imprisonment or both. So if the after conviction, if you are still operating your factory in an energy wasteful manner, you will be fined 100,000 per day. So this is the punitive element. So paying 100,000 rupees every day from a factory is not going to work. So the end result is you have to improve your facility or face all these unnecessary trouble. But we have proposed a 10% annual energy expenditure in place of this imprisonment and 100,000 a day fine. So this is somewhat summarizable. So we will see whether we get approval from the legal authorities whether this is possible. And it will change the reporting culture of many places. But fortunately, the plantation community, as I have explained, they are very much better in reporting and record keeping. So the voluntary reporting will it's what is happening now. And energy managers are appointed. They are mostly the group engineer himself, and duty often neglected because he has so much other work. These things are not done. And energy managers leave facilities and migrate to greener pastures, and leading to collapse of the system. And reporting frequencies also vary. But in the new system we are proposing, the reporting will be mandatory. You will be fined for not reporting. And if it's a firmed up duty, internal dedicated person or a external energy manager will have to be appointed and made responsible. And you cannot neglect it like you do now. So it will be a very serious consequence. And energy manager function shall continue even after person resigns. So there will have to be assurance of the continuity of this system. And the reporting cycle is fixed, quarterly reporting, and this will be enabled by an ICT platform. You don't have to fill in a lot of forms. It is purely logging onto a internet portal and providing this data. So this is my penultimate slide, I suppose. So energy information is going to be a valuable content for all the people who are engaged, especially people who are providing and analyzing this data. And these things are tightly linked with the climate action stemming from the COP21 agreement, Paris Agreement. So we have agreed to reduce 25% from our NDC commitment this year. This is the previous commitment. 20% conditional and 5% unconditional we have agreed. So all the hard efforts of the plantation community will be counted. So all of us will have to come together to do this collective. So we have to report energy reductions or also emissions and emission reductions and actually perform the important and difficult task known as the MRV, monitoring, reporting and verification of these things. Otherwise, our country will be in a very difficult position with regard to the COP21 commitments. And emission reduction projects will be very common, not only for the plantation, but everywhere. And monitoring, reporting, and verification of all projects will be the norm. Now we implement projects and we just be happy after the results are obtained. But hereafter, monitoring, reporting, and verification continuously is going to be a way of life. We have to admit that. And we have to, as a country, we have to report the emission reductions to the UNFCCC, the United Nations body on climate change. So this benchmark regulation of our facilities can be the starting point. So it will be opening up a new scope for energy reporting of large number of facilities on depending on external consultants maybe, and mandatory energy management, energy efficiency improvement of facilities, auditing and offending facilities, people who are operating more above the benchmark, and walk through a comprehensive energy reset regulator. So this is going to be a regular thing in your factories, conducting energy audits and all that. So it is going to be a very high demand item. I'm sure all of us are going to benefit from this, and that ends my presentation. I don't know whether time management, since I have time to answer your any questions. Over to Mr. Vidra Bandara. We can have a brief discussion or a question and answer session if that is possible. Any questions?
Looks like not Engineer Harsh Wickramasinghe. So thank you very much for your wonderful lecture. I think you talk about the regulations and everything, especially the participant might be interesting about the new regulation which is coming after after 2 years of time. So these are the very the fresh informations and the very good information to the participants. So I'm like to say thank you very much for sharing your experience as well as your knowledge and everything with relating to the energy management with the participants. Thank you very much for your kind cooperation regarding and for the everything you did today. Thank you very much once again. So next we are going to move into the next lecture. Next lecture will be delivered by the Dr. Tilaksiya Balapitiya under the topic of energy policy, codes, standard, and energy usage benchmark review. Sorry, it's a mistake. I beg your pardon. It's under the topic of energy information management, monitoring, and evaluation and reporting. So this lecture will be delivered by the Dr. Tilaksiya Balapitiya. Dr. Tilaksiya Balapitiya worked in electric utilities for 12 years. Since 1999, he worked as an international energy consultant, as well as he was the president of the Sri Lankan Energy Manager Association between the 2004 and 2006. He is also a visiting lecturer of several state universities, and he has accredited as an energy auditor in Sri Lanka. So this, I'm inviting Dr. Tilaksiya Balapitiya to address the meeting and give his knowledge and the experience and the everything regarding this topic. Over to you, Dr. Tilaksiya Balapitiya. Thank you very much.
Thank you very much, Mr. Bandara, and welcome to you participants. And this morning, my task is to share with you some knowledge about energy information management, monitoring, and evaluation. So my knowledge about the tea and the plantation industry in general is very limited. So, but nevertheless, most of the information collection, management, monitoring concepts are common across all industries, or even for that matter, commercial buildings. So if we, just a moment. Yes, let me proceed. Yes. What is important is good measurement and good information keeping, and to use that information to monitor your energy system. So I will discuss with you certain things that are very basic, which some of you might find to be too basic, but nevertheless, when we move around in the tea industry, we find that the information collection is relatively weak in our tea industry. So I thought I will use this opportunity to share some of my recent experience in working with on some specific aspects of the tea industry, so that I will encourage you to look at the information collection and management you have in your own factories, and also to be an ambassador to propagate the concept of information collection, management, and monitoring. So the overall objective is efficient use of energy or efficient management of energy in the industry. So I do not need to explain to you how important is energy efficiency and how important is energy efficiency as related to the plantation industries, and overall the environmental and sustainability relevance of energy efficiency. So my focus is to make sure that I remind you about the information that has to be collected and recorded and kept. So this is load profile. Horizontal axis is time. The vertical axis is power. And why do we repeatedly say that this load profile should be regularly monitored and examined in your factories? That is because it has two important features. One is that the peak is the value for which you pay your electricity demand charge. So therefore, if there is an opportunity to reduce the peak, but still continue your regular operations, there is a financial saving. The second important element is that electricity prices are different at different times of the day. So if you look at your electricity bill, the consumption charge will be in 3 components. So unless you have this profile, or at least you monitor the electricity consumption in each time window, you will not know how much you are consuming in the peak period. So therefore, either you should examine it by looking at this profile and go further to examine what is responsible for each window of this profile. I will later show you a T factory load profile, but this one is for a commercial building. Different buildings have different profiles. Of course, this is just to tell you that profiles are different across different sectors. So these are 2 different graphs we plotted for two hotels. So one has a relatively flat load profile and the other one has a fairly peaking load profile, which peaks in the afternoon. Understandable because hotels use electricity for air conditioning. This is a manufacturing industry which goes through large variations of electricity demand. And it's a big industry. I think it's a rubber-based industry. So it has large variations. Then different profiles within an industry itself. So this is a factory in which the blue line shows the total electricity demand. The green line shows the electricity consumption in the washing plant. So I tell you all these things to let you think what are your subsystems in your tea factory or rubber factory or your coconut processing facility. So what is the main system and what are the subsystems, and what is the heaviest electricity consumer in your factory? I will skip this for the moment. Now, this is a tea factory load profile. I will not mention the name, but this is a typical profile. When we looked at a range of profiles of different factories, they had completely different profiles. So I cannot say that this is a typical profile for a tea factory. Whereas I would generally say this is a typical profile for a hotel. Because as you and I know, the tea industry works on different schedules. So this particular industry, although we expect the tea industry to be heavily running the withering process in the early hours of the morning or later in the evening, for some reason, this factory has peaked at 10 a.m. in the morning. So now my question is, was there any opportunity to flatten this peak? Could the peak have been managed at the early morning peak, which was about 150 kilowatt? In this case, we have measured it in kilowatt, but CB billing is in kVA. So was there an opportunity to prevent it going up to 180, at least limiting it to 160, which should have a financial saving? So these are the matters that load profile would tell you. So, and why is this valley? So of course you may say that yes, this valley is most likely possible. This is the time that we were loading the troughs. So therefore, obviously, the manufacturing must have been running during this time, but the withering system may not have been running. So therefore, good assessment of the load profile. Now you may ask me, how do we get this done? How do we get this done? So I ask you, do you know the load profile of your factory? Do you monitor it either regularly or at least once a year or once a month? So your question will be, or your problem may be, how do we measure it? You don't certainly have instruments at the factory level. But probably you may not know that you can get this information from CEB. You can get this information from CEB because your meter records this information continuously. So therefore, in the good old days, we were telling in training courses that you will have to fix instruments and measure it. But now, as you all know, your factories have a digital meter. Whether you ask for it or not, your factories have a digital meter which keeps this information for several months in 15-minute intervals. So therefore, it is not difficult for you to request this information from CEB by writing a letter. I think they give the first, they comply with the first request free of charge. Thereafter, there is a processing charge. Of course, separately, I am lobbying with CEB and also LECO for their areas they are working on to give this free of charge to customers at least once a year, so that all customers will get a feeling as to what the consumption profile is. So coming back to the issue, what does the profile tell you? It tells you whether you are running a smooth operation, which will keep your demand charge kVA the minimum. Also, it will tell you in different time intervals, what amount of electricity are you using. So I jump back to my table here. Sadly, it is not for a tea factory, but this is a summary of a group of factories which carries several account numbers, and the factory engineer is maintaining the energy consumption during the peak time, daytime, and the off-peak time. So the concern is that in the peak time, the consumption has to be minimized because it has a financial implication. So if we use more electricity in the peak time, as you know very well, you can look at the electricity bill. Electricity will be more than 20 rupees a kilowatt hour. Daytime electricity is about 11. For most of you, it is about 11 rupees. And off-peak time, for most of you, it is about 6 rupees. So whether the electricity tariff carries a subsidy or not is relevant, but it's a different issue. And for your information, I can tell you that industrial electricity prices are subsidized by the government. But then even within the subsidy, there is a time of use pricing. So therefore, unless you know what is happening, you cannot save. So as the saying goes, if you don't measure, you don't know. If you do not know, you cannot save. It could be a financial saving. It could be an energy saving. So looking at these numbers, the factory engineer or the superintendent will say, look, our peak time consumption is 12.5% of the total consumption in our group of factories. So 12.5% is of course, the peak time is 4 hours. So 4 hours out of 24 is 4 divided by 24 is 1/6, that is 16%. So if you had a flat load profile throughout the day, it will be 16%. This number will be 16%. So you are conscious, but what I would say is that can you be more conscious? Because the off-peak period is 7 hours a day. Off-peak period is 7 hours a day at which you get electricity at half the price. So for 7 hours of the day, you are using only 15% of electricity. So of course, you will tell me that this is mostly for withering and the withering cannot be rescheduled. But I mean, you will know better than I as to whether it can be rescheduled and how withering energy can be managed. I will come to that later because withering, we know, is a large energy consumer. So moving on, the other parameters that Mr. Harsha spoke of, which we talk of very frequently, my second bullet over here, are we assessing our specific energy consumption? Are we monitoring our specific energy consumption? As we know very well, specific energy consumption is energy use divided by output. Energy use divided by output. So energy, we can separately show for electricity and separately show for biomass for tea industries, and most industries use these two fuels in the plantation sector. So energy use per unit of output, electricity use per kilogram of made tea, biomass use per kilogram of made tea. There is another parameter which we call energy intensity. That is basically the cost of energy divided by total cost. Total recurrent cost, total recurrent cost. So therefore, specific energy consumption and the energy intensity, EI, require to be monitored regularly. So that the energy consumption quantity is extremely important for efficiency assessment. So if you use progressively less energy for a unit of product, for example, per kilogram of made tea, then we can say your industry is becoming more efficient. Now you will immediately say, look, there is seasonality. In the rainy season, the withering cycles are longer. So therefore, my energy consumption will go up. Yes, understood. So therefore, it is possible for you to examine seasonality if we have all this data, or you can examine annual specific energy consumption, not monthly, because monthly rainy season could be a problem. So annual specific energy consumption should be constant because there will be a rainy season and a dry season. So therefore, the regular monitoring of specific energy consumption is to be established. So if you do not have it, please do instruct at least now to start off a simple tabular arrangement in recording this information and calculating it. I don't need to go through calculations. I'm sure you can do these calculations yourselves. Energy intensity is something I'm sure your accountants are calculating already. If not you, your accountants are already calculating. Of course, the cost of energy goes up and down if it is biomass. Cost of electricity, of course, I have to admit that it usually only goes up, not down, because electricity is largely determined by imported capital equipment or fuels. So therefore, if at all, electricity prices generally go up occasionally when various incentives are introduced, electricity prices go down. So therefore, monitoring this is again relevant because then you know what type of weightage, what weightage should you give to managing your energy. So we generally tell the industry that if your cost of energy is more than 10% of your total cost, total recurrent cost. So don't include any depreciation, but total recurrent cost. So basically energy cost, manpower cost, maintenance costs, and any interest payments. So these are the recurrent costs in an industry, not the capital cost, not the depreciation. So energy cost, if it is more than 10% of the total operating cost, we say it is an energy intensive process. So for your tea factory, for your rubber factory, or for your other plantation manufacturing facility, coconut industry, or industries under you, industries to which you advise, please do examine what the energy intensity is. There are many other information that you can collect and keep, but these are the basic information at a macro level of your facility. We will come to more details. I will introduce you to some more details. Now, what do we do with this information? Of course, this is a factory which was keeping some good records of their manufacturing process. So this is not a plantation industry. This is a ceramic factory. So why I put that in is that the management there and their engineers and their energy managers knew exactly where they were using this energy. They knew that air compressors 18%, the kiln takes 12%, because they were disaggregating energy use into different activities in the factory. So how about your factories? So when we walk into a tea factory, it was somewhat very difficult to get a disaggregation of the quantity of energy. So this, in fact, was a very rough approximation. So as you know, you might immediately ask, look, electricity costs us a lot more than firewood. So why is firewood showing a larger slice in the factory? Because as you know, firewood has a very low combustion efficiency. So therefore, although the amount of energy that might come from firewood is smaller, the input energy for firewood in this case is larger than the quantity of energy coming from electricity. So in the minimum, you need to have at least this level of a disaggregation. But my preference is for you to break this electricity slice into several subcomponents, such as withering, manufacturing, rolling, dryers, and other services. So maybe 4 different subdivisions of the electricity consumption, because don't forget, as I show in the next slide, it is the same factory, but now it is the cost of energy. So although the quantity of energy is small, the cost of energy for electricity is high. So this is natural. So you might wonder why. The reason is electricity is a refined source of energy. Electricity is a refined source of energy because there is hardly any loss of energy when you use electricity. Whereas biomass, you have a combustion efficiency to handle. So therefore, in this particular factory, this is a little bit of outdated information, but still the price ranges, the cost ranges are the same. So electricity accounted for 62% of energy bill of this particular tea factory. So moving on, now, what do we use this information for? So once again, this is an example from a tea factory. Sadly, my apologies for those of you from the rubber industry and the coconut industry. I do not have any case studies or examples to show at this moment. So specific electricity consumption, the factory was reporting 0.79 kilowatt hour per kilogram of made tea, and the benchmark that has been published is 0.63. So therefore, on paper, there is a potential improvement of 20%, or on the other hand, 20% saving of electrical energy was possible for this factory. Now, I have to tell you that 0.79 was what we calculated for this factory. The benchmark is a result of a research study. I don't remember where I got it from. Probably it is from the Sustainable Energy Authority information or from some previous studies. So benchmarks are good, but on the other hand, benchmarks are very industry specific. As you know very well, the low country, the mid country, and the up country have different processing durations, different quantities of energy that may be used. Rainfall is different. Processes itself is different. So therefore, benchmarks have to be used with caution. So I would tell the factory manager in this factory, look, don't feel bad if your factory is reporting 0.79 against 0.63. Or if your factory for thermal energy, that is biomass, is reporting 2 megajoules, whereas the benchmark is 1.78. Because the benchmark may not be representative. Your process, your situation could be different to other factories. So, but still, it indicates that somebody else is manufacturing at a level of consumption below your level of consumption. So therefore, you need to examine where the opportunities are. What I would generally prefer is this kind of an arrangement. That is, for you to establish your own benchmark. For you to establish your own benchmark. Now, this curve is not for a tea industry. It is a manufacturing industry. I brought this curve to explain to you the principle behind it. And one reason I cannot present a curve for the tea industry, at least, is that I do not have enough information for a given tea industry to do this. Because unlike many industries, the tea industry, I believe, has a seasonality element. So that seasonality element we have to handle very carefully. So therefore, I'm bringing you an example from a manufacturing industry. Now, what have I done? I have the input raw material here, which represents the production. On the vertical axis, I have the specific energy consumption. That is energy per ton of output, or in your case, megajoules per kilogram of made tea. So then I plot a number of operating points. So each one of these dots represent a month in the past. 1 month. So if the industry is heavily seasonal, there will be a lot more scatter. There will be scatter quite a lot. But this industry, fortunately for me, is not so seasonal. So therefore, but of course, there have been months in which the production has been 50 tons. Whereas in the peak, it has gone up to almost 350, a ratio of 1:7. Obviously, your tea factories, rubber factories, and coconut processing facilities do not have this kind of a variation, because these factories respond to customer demand. Whereas your industry, I believe, keeps on continuously manufacturing. So therefore, you may not see this much of a wide variation of production on a monthly basis. But I expect your industries to show quite a lot of fluctuations. So fortunately for me, I got most of the points lying on this curve. It's a little bit of a mathematical y equals a coefficient times log x plus another coefficient. And I get r squared is 0.92. So statistically, it is a good fit. So you can get your engineer or technical officer or even accountant to just jump into Excel spreadsheet, and it will do the diagram for you. Now coming back to it again, this benchmark is your own benchmark. Unlike here, it's not somebody else's benchmark. So I always recommend that you establish your own historic performance, and this line is your borderline. Next month, if your point of operation is above this line, you have violated your own benchmark. If you are improving, then the next month dot has to be below this line. It could be anywhere here. It could be anywhere here because your production could be different. So your next month dot, if it is lower, then you are below your own benchmark, which means you are good. So these are the simple things that you can do without getting, you don't need a consultant to do that. You already have this information. These dots are calculated in terms of energy. And energy, electricity is available in your electricity bill. Your firewood consumption is available in your factory records. Your production for the horizontal line is available in your factory records. So this is something you can do it yourself. So I will skip this slide and this slide as well, and straight away get on to this. This one is a specific energy consumption pattern of a particular manufacturing industry, once again not a tea industry, and how this company was monitoring its dwindling or reducing specific energy consumption. So you will remember, specific energy consumption is energy per kilogram of product, not price, quantity. Because price varies here and there, even for political reasons, prices go up and down. But if energy consumption is going down, so then the achievements are good. So look at this factory. This is actual data. This is not fictitious data. This factory, with a value of 65 in January, by December it was 58. And we'll look at the following year. And the following year, the company is seeing some kind of a seasonality. So, but the overall trend is down. So he started off with 65 here, and he ended up with 53 at the end of the year. So that's a good situation. And then before I close, because I have been asked to economize on my time, I will show you some recent studies we did in the tea industry. As follows. Tea industry for the last 20 years has been requested to manage the airflow to the withering process. All of you know that. So I, being one of the people who were associated with the initial studies, recently we thought that we should do a baseline study as to how the industry is performing with regard to airflow management to the withering process. So I don't need to explain to you about the withering process. You know much better than we do. So withering is a heavy electricity consumer. So therefore, the energy use in withering has to be managed such that, as the tea industry experts have taught us, that if withering is managed well, the product quality also improves, as well as the electricity consumption also reduces. So we went to a particular factory. I will show you a different set of information. Let me close this share and share a different file. All right, you will be seeing a set of graphs on my screen. So A is our factory. I don't need to tell you the name. A is a factory and T is a trough. All right. So, and T1, T2 means trough 1, trough 2. If I say A1, it is day 1. And if I said A2, it is a second day in the same factory. So coding is like this. So therefore, now here is how the factory was managing their withering fan power input. So of course, we expected the company to manage this somewhat in a different way, but at least these operators were managing the withering process, and it was a fairly long wither, as you see, almost 23 hours, and had been on full power for nearly 16 hours, then shut down and restarted in the 22nd hour or so for another hour. So see on the same day, a different trough, same size, and it was run for 11 hours, very slow speed for several hours, and about 1/3 the speed for some time, and a shutdown, short shutdown, and about 20% of the speed until the end of the wither. So how do we measure this? We went to the factory and we fixed the instruments and we asked the operators, you ignore us, right? Don't assume that we are there. You just operate as you do. You just operate as you do, because we are just doing a baseline study as to how the industry has absorbed the concept of managing the airflow to the withering process. It has a energy efficiency undertone. It has a quality improvement undertone. So, and on the next day or the following day, I don't remember, but another day, so the operations were similar, and again full speed now. And the other trough, it's going through certain stepped reductions. So this is kind of something a little bit closer to what the previous research showed us on how the withering airflow should be managed. So, and on the following day, look, it was really, really long with running up to 40 hours. 40 hours. So there was another reason for it, because this went over a weekend. So therefore, they were running weekend or 2 holidays, I don't remember. So they went through a very long withering process. So these were what we examined, and we also measured the moisture reduction, because moisture reduction is the objective of withering. So I thought, now that I'm meeting a group of enthusiasts on energy efficiency from plantation industry. So we actually started off with whatever the moisture level. We measured the moisture level in a sample, in a couple of samples of each trough. So each line represents a withering run of a particular trough on a particular day. And you see the 2 long lines, horizontal axis being the time. The 2 long lines are the ones I showed you last. And the shorter ones, which were running for almost 24 hours, are the other 4 runs that I showed. So if we say the starting moisture level was the reference, and what we drew was moisture reduction curves. So all of them ended at a moisture level of the range of about 60% of what it was. And some of them ended up with 70% of what it was. The amount of moisture embedded in the tea leaves in the withering process. And of course, we measured the moisture level, more accurately, moisture level. Vertical axis is weight of the sample, but moisture level was separately measured. So the industry seems to be following some kind of a practice. And as we see here, the industry achieves a range of moisture levels. But to us, the industry does not seem to have a clear guidance on how energy should be managed in the withering process. And we studied 2 other factories as well with different results. So what we see is that an effort is being made to save energy. Companies have invested on variable speed drives to control the fan speed. That's how they can run it at different speeds. So the investment has been made, and some savings are happening. Some savings are happening because in the good old days, what would have happened? This fan would have run at full power the whole 24 hours, and the damper would have controlled the airflow, which will not cause this kind of energy saving. So therefore, it's benefiting already, but there is a potential to further improve energy saving in the withering process. So this was our most recent findings in our studies, and these studies were done in the month of March. Not so long ago, in the middle of two lockdowns, we quickly ran to these factories and did these studies. So what I have to take out of this is that good work on energy efficiency improvement has been implemented. Certain investments have been done, but now is the time to further optimize and save more. And energy saving in this case, as the experts tell us, saves energy and improves quality. So therefore, there is some more specific interventions to be done. I'm sure in TUT machine, in rolling, there are similar opportunities to improve energy efficiency. In the final manufacturing process also, there will be opportunities to improve. So we only looked at basically one of the three main electricity consuming systems in a tea factory. So I would stop there, perhaps leaving a few minutes at least for questions. So I did not take my full 1 hour. I think I took only about 40 minutes. So your questions are most welcome. If you want to discuss anything specific, I can put the slides back on the screen. Maybe I can ask a question as to, for those of you who are from the tea industry, I'm sure most of your factories are equipped with airflow control, popularly known as variable speed drives. Is there any monitoring work going on as to how the operators are using them? Can somebody just give some experience that you have? Fine. Any other questions? Have any one of you been able to look at the load profile of a factory or your factories? Has anybody asked CEB, can you give me my load profile? Because as you know very well, your electricity meters are read remotely by CEB. Occasionally, when the signals are not good, maybe they will visit and read. But usually, the standard practice is for remote reading of your meters. So anyone who has experience, because as I told you, I have been telling CB and LECO, please give this load profile voluntarily to all your customers, and then with a comment on the load profile, which can be automated as well. And then tell them, how it can be used. Anyone who has experience in looking at a load profile, because these are opportunities available to save energy. I know some of you may be having renewable energy facilities on site. It could be rooftop solar or a mini hydro or a micro hydro. So that's conversion of a natural resource to electricity, but that does not make energy efficiency less important. Energy efficiency continues to be important.
Dr. Shyamalabhati, if there is no any formal questions from the audience, I think we can move into the next sessions and we can wind up. So
Sure, certainly.
Yes,
certainly. I wish I had the opportunity of meeting you in person.
Yeah, we all do.
Face-to-face interaction is much better.
Much better, yeah. We
So,
all do.
but nevertheless, I suppose we can use this difficult window of the industry to interact and improve our efficiency. Occasionally, I have had interactions with tea manufacturers in Kenya. With my work on renewable energy, because I advise various governments on renewable energy related policies. So in these activities, I have met tea manufacturers in Kenya and India. Of course, what I see there is that manufacturing processes are being modernized, perhaps much faster than we see in Sri Lanka. So, and the objectives are many, but energy savings are also one of those objectives in the modernization. So, and if we come back to the withering process that I have been studying in the recent past. In fact, I started off this baseline study as an exercise for my undergraduate trainees. You know, we get undergraduate trainees from engineering universities and from technology faculties. So therefore, I always look for opportunities to put them into some hands-on work. So last year, I thought this is a good opportunity. It was 20 years now since the concept was introduced to Sri Lanka on airflow management in withering. So it's a good time to look back as to how much we have done and what more can be done. So of course, I know TRI is conducting continuously research on that. We are in touch with them, but I would suggest that you too also look at your own factories in your group or factories you have some say on to examine whether airflow management is being done professionally. So thank you very much.
Thank you very much, Dr. Siambala PTA, for your kind cooperation regarding and sharing your experience and the knowledge with the participation with the NIPM. And thank you very much bringing those ideas and putting those ideas into the table for a formal discussions. Thank you very much once again for your kind cooperation.
Bye-bye.
Bye. Thank you. So the next sessions, next lecture will be delivered by the Mr. Sanath Kissiri. Is an engineer, a profession by engineer. I will deliver this lecture under the topic of energy saving opportunities and practical ways of energy conservation. To more details about the engineer Sanath Kissiri, he's got his graduate university degree from the University of Moratuwa, as well as he got a MSc in Sustainable Energy Engineering from the Stockholm University located in Sweden. As well as he's got few professional qualifications, just like a member of the Institute of Engineering, which is known as IESL, as well as he's an accredited energy auditor of the Sri Lanka Sustainable Energy Authority. Moving to his employment profile, he has held as many positions from 1996 as a demonstrator, quality assurance engineer, mechanical engineer, head of the energy efficiency at the SCA Sustainable Energy Authority, moving to the director to the Sustainable Energy Authority, as well as director of the energy management of the same institution, as well as now he's currently positioned director industrial service sector with the Sri Lanka Sustainable Energy Authority. And he has undergone many trainings, including foreign and the local, as well as he has given his knowledge and the capabilities to the energy auditing industries, to the plantation industry, as well as to the other industries as well. So I would like to warmly welcome Engineer Sanath Kissiri to deliver the lecture about these practical ways of energy conservation. Over to you then, Mr. Kissiri. Thank you very much.
Good morning, Mr. Bandara. Can you hear me?
Yes, we can hear you, Mr. Kissiri.
Yeah.
We can.
Okay. Okay. Good morning once again. So my presentation is energy saving opportunities and practical ways of energy conservation, right? So actually the given time is 1 hour, I think, to discuss the energy conservation opportunities in basically in plantation sector. 1 hour is not possible. Anyway, I will try to discuss with you some important matters. Before I start my presentation, I will just see what is the unit of electricity, because we know in basically manufacturing process we are mainly use electricity. So the knowledge, the how we measure the what is the unit of electricity is very important. The understanding of basically we know the unit of electricity is 1 kilowatt hour. That means
Excuse me, Mr. Kishiri, sorry for interrupting, but sometimes your line is quite breaking and your voice is echoing when you speak.
actually maybe now it's okay.
Same echoing is there.
So how about now?
Now much better.
Much better. Okay.
You
So,
continue. If there is something, I'll let you know.
Okay, that's fine. Okay, we know the unit of electricity is kilowatt hour, and if we look at the one element, which maybe bulb or any other electrical appliance, the capacity is given in kilowatt hour or watt. Because if it is a small one, the capacity is given in watt. So if we use this equipment for a certain period, right? Say 5 hours or 6 hours, the multiplication of the capacity and the working time will give us the energy consumption of that particular equipment. So we know the kilowatt hour is mainly depend on the capacity, the size of the appliance that we are use, and the time, right? Time and the capacity is important parameters that depend on the energy usage. If we consider this one, yeah. If you take another example, for example, say we have 1 kilo equipment appliance. We use it for 1 hour. That means it consumes 1 kilowatt hour. Say we have 500 watt equipments. We use it for 2 hours. Again, it consumes 1 kilowatt hour. Say we have 100 watt equipment, that is 0.1 kilowatt hour. We use it, if we use it for 10 hours, it is also consume 1 kilowatt hour. Say we have 2 kilowatt hour equipment, we use it for half an hour. Again, it is also consume 1 kilowatt hour. If you look at this example clearly, we can see the energy consumption is not only depend on the size, but also depend on the time. That is very important thing when we consider the energy consumption and when we look for energy conservation measures. That's why I will, before I start my presentation, I get that example. Right, that is I'll show you another graph. I think, I don't know whether you have familiar with this. This is the energy daily demand curve of Sri Lanka. You can see y-axis represent the demand in megawatt hours. X-axis represent time of day. You can see basically after 6:30 and 10:30 in Sri Lanka we have huge peak. Because of that, if any industry or any production facility use electricity during that period, the utility will charge more cost for that energy, because it is difficult to generate electricity during that time. We know electricity is not normally electricity is difficult to generate and store, because unless if you use battery usage of battery to storing electricity is very difficult. Because of that, utility what they do is they generate at the time of requirement. So we know during that time, because during the 6:30 a.m. and 10:30 utility used a lot of thermal energy plants. That's why because of that, the electricity generation cost during that period is very high. Because of that, to discourage the users to use electricity, that means to avoid the wastage, right? Utility charge higher rate of cost for that electricity during that period. That the nature of the that thing is also very important if you are doing some energy, if you are managing, if you are planning some kind of energy management activities. That's why I present this graph to you. Right. Okay. When come to the optimization of energy, basically there are 5 approaches I can show you. Right. One is avoidance of unnecessary consumption, because if you remember the previous equation, the kilowatt hour is depend on kilowatt into time. If you switch off unwanted appliance, definitely you can reduce the kilowatt hour. And next one is reduction of specific energy consumption. That means if you get the particular task, if you can use more efficient appliance. For example, say I'm using the air conditioner, right, to get the thermal comfort in my room. I use a window type that is very old. If I replace that window type one with the latest VFD type one, I can get the same service using less energy. That is called reduction of specific energy consumption. That means simply the use of efficient appliance means reduction of specific energy consumption. Improving effectiveness means that is another way of because in some power generating plant we know the when we generate the electricity in thermal plants, the chimney escape some hot flue gas escape through the chimney. That flue gas contains some kind of heat content. So if we can use that heat content to generate another form of energy, we can improve the overall system efficiency. That's how we can improve the efficiency factor. The fourth one is energy recovery. Then simply, if you have a waste in a certain area, if you can use that waste stream into input as another area, you can recover that energy, and thereby you can improve the overall system efficiency. And finally, if you can use renewable energy sources to meet your energy requirement, thereby you can reduce the grid energy consumption. Definitely, you can improve the energy efficiency, utilization efficiency. Thereby, you can reduce the cost of energy. Those are the 5 strategies, right? Yeah, these are the one I discussed previously. Avoidance of unnecessary consumption. So for that we can use some timers, right? Timers we can use because the timers are not that expensive. For example, to reduce the energy wastage in washrooms, we can use timers, right? Some corridors, we can use timers because people are not interested to switch off the light, idling light in corridors and washrooms. Thereby, instead of human use, we can assign this task to some kind of timers, right? Thereby, we can reduce the unnecessary consumption, right? Specific energy consumption reduction, as I mentioned earlier, instead of small units, old unit, we can use high efficient equipment, thereby we can reduce the energy consumption. Efficiency factor, as I mentioned earlier, the energy wastage through the exhaust, we can use some kind of to generate some kind of energy, thereby we can improve the energy efficiency. And recovery, I have already discussed. And renewable energy, actually, if we consider renewable energy, there are many kind of options. Biomass is one option. Actually, I think already the industry we successfully use biomass, because earlier a lot of furnaces are running by fuel oil, but nowadays most of the factories they switch to the biomass from the furnace oil. And photovoltaics, that means solar power generation, that is also one possible option. And wind power, in certain areas we can use wind power to meet our energy demand. So when it comes to the energy application, actually, office spaces, these are the energy application: lighting, ventilation, and air conditioning to run to operate appliances, to pump water, and sometimes to heat water. We use electricity, gas, and biomass. Those are the energy application. If you look at the office spaces, because plantation sector, you may have some managers bungalow and office head office complex, right? So those areas, if you the thorough knowledge of the energy conservation opportunities in those areas is also very important, right? So when it comes to the energy conservation, because air conditioning is very important, if you look at the energy balance of the office space, air conditioning consume major part of the energy, right? It's the biggest energy consumer. So maintaining air conditioning system is appropriate manner is very important. So we'll see what are the energy conservation opportunities, especially in air conditioning. Actually, when it comes to the air conditioning, thermal comfort, to satisfy thermal comfort, you have to satisfy certain parameters, because most of the people thought that only the temperature, because they try to take the remote control and try to reduce the temperature. Actually, thermal comfort is not only the temperature; it mainly depends on the relative humidity, air movement, and fresh air ventilation. So here I have mentioned some recommended levels. If you are maintaining those parameters given in this range, then only you can have a thermal comfort, right? So that is very important when it comes to the energy air conditioning. So if you look at the energy balance, as I mentioned earlier, energy balance, most of the places like office building and some banks, hotels, air conditioning is the biggest energy consumer. That's why maintaining the air conditioning system in a proper manner is very important if we try to reduce the energy consumption, right? So the important thing is, as I mentioned earlier, if you reduce or increase the temperature of the air conditioner by 1 degree, because of that, your energy demand will increase or decrease by 4%, right? That's why it is recommended to maintain the space temperature at the appropriate level. For example, for the countries like us, it is recommended to maintain the space temperature at 26 degrees. But we have seen in most places people are maintaining space temperature at 22, 20, and rather low temperatures. But to get the proper thermal comfort, you have to maintain temperature at 26. Thereby, you can achieve both thermal comfort as well as the energy efficiency, right? Other conservation opportunities, because we have seen a lot of places, right? There are, because normally air conditioning space should be constructed closely, because if there is a gap, there is a air exchange, thereby the energy consumption will increase. So avoidance of infiltration exfiltration is very important, because we have seen most of places people are not worried, not pay attention for the door closers, because it is recommended to most of the time, right, to install the door closers. If there is a door closers, it is recommended to check the function of the door closers frequency, whether the door is closed properly or not, right? And other thing is idling of air conditioners, because as I mentioned earlier, if you look at consider energy consumption, major part of the energy consumption of the office building is goes to energy consumption. So idling operation should be avoided as much as possible, right? So awareness also is very important, right? And other thing is shortcoming in AC spaces, because we have seen most of places some heat emitting appliances, kettle, boilers are operating inside the AC space, So because of that, the heat release during that operation of that equipment, that heat has to be expelled through the air conditioner. That ultimately you have to pay more money for the electricity. So those kind of, if you have some tea room in a AC space, you can separate that one. Some heat emitting equipment you can identify, right, and remove that equipment or appliances to the non-AC space. And sometimes we have seen there is no doors to separate the AC space and non-AC spaces, because you select the small AC depending on the size of the space to meet the air conditioning requirement. But if there is no door between a non-AC space, AC space, your space ultimately will increase. So the small air conditioner try to meet the air conditioner requirement in both places, and because of that it runs continuous, right? So because of that, the air conditioner will the lifetime will be shorter, right? So those are the main shortcomings in basically we observe in most of the office spaces. So you have to avoid those shortcomings, right? Another thing is, if we can reduce the heat gain through the windows and doors, and right, definitely we can reduce the energy consumption for the air conditioner. For that we can use some infrared radiation, some heat reflective films and curtains, right? Sometimes you can grow trees, you can apply some shadings, right? There are a lot of methods you can reduce the external heat gain, right? And other thing is, one is proper maintenance is very important. So it is advised to clean the air filters periodically, because we have seen sometimes, because once you install the air conditioner, you never clean your air filter. Because of that, the air conditioner will damage very quickly. And other one is replacement of old and inefficient air conditioner, because nowadays we have a lot of energy efficient equipments. Say if you have an air conditioner in 10 years, 12 years old, definitely there is a possibility of reducing energy by replacing those kind of old inefficient air conditioner with inefficient appliance. Other one is because we have seen some places there are a lot of individual air conditioners, right? You can see if you look at this table, right? I have mentioned some. If you look at the type of ACs, split air conditioner, the COP, that is the way of expressing the efficiency. COP value is 2.2 to 3.3, 3.2, right? But if you come to if you consider the larger electric chillers, right, definitely the COP value is twice of the split heaters. So if you have a number of units that's in split unit, rather than operating those systems, if you can have one large chillers, definitely you can reduce the energy consumption. For that, you have to conduct a study, right? After studying the condition, your environment, and after collecting the measurements and the data, definitely we can see whether it is feasible or not. But most of the cases, you see, it is feasible to have one large system rather than operating a large number of split units, right? Those are the main conservation opportunities. When come to the lighting, because the lighting, most of the office spaces and factory building, we use lighting to illuminate the, right? When come to the tea industry, actually the overall out of 100, the energy consumption for the lighting is in the range of 10 to 15%. And when come to the lighting, there are two definitions. Lumen. Lumen is the total amount of visible light. That's what we want, right? Total amount of visible light emitted by source, right? But visible light in different direction is not important. So because of that, we have the defined other terms, lighting lux. that is lumen per square meter. That means if you have a table, right, the lumen per square meter of this table is called lux. That is the important parameter. If we are referring the activities, for example, corridors, we say the required lux level is 50. Reading room, reading table, we say required lux level 300. Likewise, we, to mention to specify the required light level, normally we use lux. And other one is lamp and light. Lamp is the single unit, but if we come with the other accessories like reflectors, that is called light. You have to make aware those wordings as well, right? Another important features of the lighting is color rendering index, because certain light has certain color rendering index. You can see this if you very closely refer this table. You can see different light sources have different color rendering index. Color rendering is the ability to see the true color, right? If the color rendering is 100, right, under that light you can see the true color, because we know under sunlight we can see the true color. The sunlight color rendering is 100, right? Basically, incandescent lamps use the color rendering index, right? Because depending on the requirement, right? Depending on the your process, you can select the color rendering index, right? Different type of lights. You can see the LED light, tube lights, halogen light, right? Right. There are a lot of, when come to the lighting, there are a lot of lighting available in the industry today, right? I'm not going to discuss. Another important thing is comparison. That is, if we look, because in this table you can see there are comparison. First column you can see the type of lamps. The second one is efficacy. Efficacy means if you provide 1 watt of electricity energy to this lamp, it will give, because say consider first one, incandescent lamp. If we provide 1 watt, it will give 12 lumen output, right? Lumen, as I mentioned earlier, lumen is the visible light, right? If we can increase, if the value is higher, that is very important, because that's why today nowadays LED play major role, because instead of you can see in LED bulb efficacy value is in the range of 160 to 200, because that means if we provide 1 watt, it will give nearly 180 lumen output, right? But in case of incandescent lamp, if we provide 1 watt, it will give only 12 lumen output, right? That's why nowadays, instead of incandescent lamp and other low efficient efficacy lamp, people are moving to the high efficient LED lamps, right? And other important thing is lifetime. You can see lifetime of different light. LED lifetime is higher, and incandescent lamp it is in the range of 1000. So if you use incandescent lamp, not only the energy, you have to replace frequently, right? So you have to consider those factors as well. And ballast, if you consider basically we have seen in most of the tea industries, people many places use tube light, right? That linear fluorescent lamp. Normally linear fluorescent lamp employ ballast to control the voltage and give the higher voltage, right? But normally in traditional tube light, it comes with the magnetic ballast. Is also, you can see magnetic ballast, standard ballast, it consumes 14 watt, right? The lamp consumes 36 watt, ballast consumes 14 watt. Altogether, it's in the range of 50 watt. But if we move to the traditional lamp, to the T8, that is a thinner lamp, right? Thinner diameter, smaller diameter lamp, you can reduce the energy consumption, right? Instead of conventional ballast, you can use electronic. This ballast, magnetic ballast consume 14 watt, whereas electronic ballast consume 2 watts. So altogether, the proposed system, the T5 system, T5 lamp together with electronic ballast, total system consume 26 watt, almost. You can get 50% reduction, right? So if you are if you are factory, if in your office, you are using electronic tube light with magnetic ballast, definitely you can reduce, you can replace those lamps with the T5 and electronic ballast. Thereby you can reduce the energy consumption by 50%, right? And other one is lighting, in summary, lighting optimization, right? We can use natural light rather than artificial light. If we can use natural light, if we can use more and more like natural light, definitely we can reduce the artificial light, and thereby we can reduce the cost and reduce excessive light, because that's mean the is very important, because we can see some places without planning, without estimating the lighting requirement, people do the installation, and because of that, some places may have excessive light, some places there is less light, right? So we have to avoid this one, and for that we have to identify the requirement, and after that we do the it is recommended to do the lighting design layout, right? Use of LED, and that's been efficient lamps, right? Because LED, low maintenance, right? And low energy consumption. And reflectors is also very important, because some lamps, the light will emit every direction. So to get rid of this, avoid this, and reflect into the desired direction, we employ reflectors. So installation of reflectors is very important, especially if you are using a tube light, right? Definitely you have to have a reflectors. But although you have reflectors, because with time the dust particles and will deposit, and the reflection efficiency will reduce. Therefore, the cleaning of the reflectors is very important. As I mentioned earlier, other one is electronic ballast. Rather than using conventional ballast, if you can use the electronic ballast, you can reduce the energy consumption for the lighting. Those are the key energy conservation measures in lighting, right? So in summary, you can see this table figure, right? Some conservation measures together with energy saving potential, right? For example, 11 LED reconstruction, because it gives higher energy saving, as well as it needs a much larger investment, likewise, right? But when come to the daylighting, right? Daylight use, because if you do the proper planning, it gives there considerable amount of energy saving, but doesn't require much higher investment, right? Likewise, you can see your options as together with investment and the saving options, right? When come to the, I will talk to another important aspect, water. Actually, water is also very important aspects we have to consider, especially in office building, right? Because I will show you, because nowadays, earlier people use systems, because larger systems, because it has a 1+ system, we say big system, and then later on designers change the design and design small systems, right? They reduce the amount of water usage, right? And then later they found that because during the flushing we use this command for the solid waste and liquid waste. So for the liquid waste we don't need much water. Because of that we have designers design dual flush systems. You can see there are two buttons, right? Because if you for the liquid, once you press the smaller button, it will use 3 liters of water. The other button, if you press the other button, it use 6 liters. Thereby, if you have a large system, right? If you instead of large system, if you replace the larger one with the dual flush small system, you can reduce the water consumption considerably, right? Right. Other one is because with time there may be a leakage in the system, right? To because, for example, say you have a older one, right? Older system, right? I will show you some cheapest option to convert the older one to the energy water efficient one. Take a mega bottle and fill with water and use the cap and put those water bottle in system. So once the water consumption, right, rather than new one, right? That is a low cost option, right? When come, okay. Can you hear me, Pandara? Hello. Right. When come to the taps, right? Rather than standard taps, nowadays there are water efficient taps. If you switch from conventional tap to low efficient taps, then only thereby you can reduce a certain amount of water, right? Those are the showers also. When compared with the conventional showers as well as water efficient showers, you can see the considerable amount of water can be reduced, right? Right. So now we move to the process machineries, right? Like in process machineries, we are using, because in tea industry basically we have a withering process and then rolling and drying and packing and sorting, right? So those are the main activities, services. They are blowing, we have motors, right, and rollers. Lighting, we use light. We have a furnace or boilers. They are in that process we generate hot air, and we have a dryer to dry the tea, and we use water pumps. Those are the main energy applications, right? So when come to the energy conservation opportunities in processing, and this is the if you look at the electricity bill, not like not similar, it's not similar to the one we received in our domestic bill, because in a domestic bill only one charges for the kilowatt hours, but in industry we have another charge for the kVA, right? So we have demand charge as well as unit charge, right? And demand charge, because we know the CB will monitor the demand and calculate the average in 15-minute interval. Because of that, because you can see in a because normally the demand, right? If you look at the tariff, right, demand 1 kVA charge 1,100 rupees, right? So maintain the demand is very important, right? Because of that, because of that, because of that, people are using sometimes power factor corrections bank, right, in their premises. But most of the places we have seen there is no capacitor banks and power factor correction bank in their premises. So what you can do is you have to first log your demand using the energy logger. Thereby you can see, is there any possibility to reduce the improve the power factor and thereby reduce the demand cost. But if you look at the electricity bill, you can't come to the conclusion because it doesn't give any indication of your power factor. Definitely, you have to have you have to get the you have to log your demand in certain periods, say one day period or 2 day period. Then only you can get some idea. Okay, this is, if you have a power correction system, you can see okay, this my system is still good, no need to further improvement. So sometimes you can see there are further improvement, then accordingly you can act, right. To reduce the KVA, right? People use capacitor banks, but though you have a capacitor bank, servicing of capacitor bank is also very important. Other one is managing your major loads during peak time, because once you get the profile, you can identify, okay, this is my peak time, so you have to be careful to minimize to avoid the major loads during peak time if possible, because sometimes it is difficult to shift the load, but some instant you can find there are some rooms to replace the shift the major loads during peak time, thereby you can reduce the energy, right. And other thing is use of rebound motors, because we have seen in the industry most of the time people are using rebound motors, because those motors consume more energy, right. So this table shows you the black tea manufacturing process as well as the energy consumption. You can see, if we look at the electricity, the specific energy consumption is in the range of 0.5 to 0.9. Thermal, because mainly thermal energy is used in withering process and drying. When compared with these two processes, actually drying process consume more energy. It's in the range of 60, and thermal energy, withering consume 40% of the thermal energy. Right, out of withering, rolling, and fermentation, drying, and packaging, withering electricity consume more in the withering process. That's why your withering system you have to maintain carefully to reduce the energy consumption. Right. When come to the firewood, because as I mentioned earlier, most of the places nowadays people are moving to the biomass from the furnace soil. If you look at the energy balance, say we provide 100 of energy as input, you can see 45% is lost during a stack and surface losses, right. So to conserve the energy, we have to reduce those losses, right. We will see how we can reduce the energy consumption in those loss areas, right. Because as I mentioned earlier, in firewood usage, because most of the places there is no enough firewood spaces, right, a space for storing firewood. Because of that, most of the places we used to use raw firewood. If you see, because if you consider raw firewood, its moisture content is the raw firewood, because some part of the energy is used to evaporate the water. Therefore, definitely the useful energy portion will reduce. You can see, if we improve if you reduce the moisture content, right, and the corresponding firewood saving, you can see, because those figures we derive from the trial and error basis. You can see, if we reduce the moisture content by 10 to 10%, definitely you can reduce your firewood consumption near in the range of 11%, right. Right. Other thing is avoid use of firewood, right. You can see, because you can see in this graph, the water will drain, right? Water drain, right, during combustion, right? Right. And to dry the plywood, if you can maintain a good plywood storing system like this, definitely you can reduce the moisture content, right? But you don't need to spend more money, but right, please consider this matter, because we have seen, because we have conducted energy audit in the industry in most places, right? But most places, right, people are not maintaining or not having a good the world management system, right? Unfortunately, right? You can see moisture content by stacking the plywood like this. You can easily come to the moisture content will reduce to 25% within 5 weeks, right? Other thing is splitting is very important, right? Right, because you can see some trial tests we conducted together with TR Ratnapura, right? In trial 1, the normal operation, trial 2, we reduced the plywood size to 1 meter length and feed in a constant time interval. Then in trial 3, we feed measured quantity of plywood, 0.5 meter length plywood in constant time interval. Then if you look at the, then we calculate the specific plywood consumption. This is the test results you can see in trial test, because if you reduce the size and then definitely the specific plywood consumption will reduce drastically. So you have to have that kind of practices in your places, right? Some pictures of splitting machines. Right? So the areas, because boiler operators not care of the boiler operation, because they try to and try to burn, because of that the problem is because of that there is a uneven flue gas temperature, right? Uneven flue gas temperature means this will result uneven inlet temperature to the dryer. Because of that, you sometimes may have under fire and low fire, and it will affect the quality of the tea, right? Right. You can see in this graph some effect of uneven feeding of fire, right? Right, XSR is required to have a complete combustion, but if you increase more and more, if you give more and more air, that is also lost. So you have to maintain appropriate level, right? So so you have to adjust the burners according to the fuel peeling rate, right? That's why because once you adjust the burners, right? Because you don't need to change, because of that we advise you to, because in most cases we advise you to not to feed different size of plywood, because some people use sodas together with wood blocks, because in case of sodas it doesn't need more energy, more air to combust, but in case of wood blocks, right, it needs more air. But if we feed together with sawdust and wood block, right, it is difficult to maintain the required air flow rate, right? That's why if you using sawdust, you have to adjust the burner air damper to that level, right? Then once you switch from sawdust to wood block, then you have to change another position. So don't mix and put, right? That is important area. right? So when come to the summary, firewood combustion solution, use clean and size, smaller size, moist dried and dried firewood, and regular peeling rate is very important. Optimization combustion air, that is also very important, because if you maintain those kind of things proper manner, definitely you can reduce the firewood consumption, right? Right. In weathering process, we use air to remove the moisture from the green leaf, right? So we use axial fan to in this withering process, right? You can see some schematic diagram of the withering process. In we have a withering chamber and withering trough. We load green leaf on the withering trough, right? This is a picture, schematic diagram of withering trough, right? Right. And especially, I want to mention you because some fans, right? We can change the pitch angle, and thereby we can tune up the fans to get the required flow rate. For that, actually, we have installed together with, I'll show you later, we have installed some withering fan test rig at TRI. You can use the service of that facility, because once you can using that test rig, you can adjust the fan according to your flow requirement, right? This is some formula, because how we can calculate the airflow requirement and power of the fan, because I will just mention here. You don't need to worry about this, because we use this formula later. I'll show you some. The airflow measurement, we can measure using this kind of thermometers, airflow meters, right? Okay, so because when we are conducting audit, we have seen in certain cases people are employing oversized motors in withering truck, right? So this is because this slide show you how you can compute the required size of the motor according to the dimension of the trough with loading capacity, then you can easily calculate the required size of the motor, right? Using this formula, right? You can see according to this calculation, right? The motor power is difficult. Right, and see my motor is oversized to undersized. If it is oversized, you can next time you can replace the correct one with the correct one, right? When come to the withering, some measures: correct loading, spreading of leaf is important, correct loosening and turning leaf at correct time, right? If it is wet leaf, 2 turning is required, otherwise single turning. Dry season, single turning is there, and close monitoring is required, and pre-calibrated hygrometers is very important, because to get the proper weather, we have to maintain the wet bulb and dry bulb temperature, and is important. Dampers of the position, the maintaining of dampers, functioning of the dampers is also very important. Those are the key areas we have to look at. And because some cases, some people still using hot air ducts system to give some thermal energy hot air to the withering area. Nowadays, if you have a boiler and hot water boiler or steam boiler, the radiator system you can easily employ, right? Thereby you can reduce the but still, if you have a duct system like this, especially if your factory is located in up country, because during night time, most of the time the temperature will go down. Therefore, to reduce the energy surplus energy loss, it is advised to insulate the duct properly. Right, that is also another important area you have to think. Right. Right. Those are some other parameters, right? You have to think. I'm not going to discuss. And sometimes we have seen blowholes during withering process, because we know during withering because withering blowhole may happen, right? Because of that, some energy wastage. So you have to avoid this kind of operation. Actually, if you are employing VFT, right, easily you can avoid blowhole, because in normal withering process, the motor run at a constant speed. We reduce the airflow using dampers, but using a damper to control the airflow is not an efficient manner. It's sometimes dampers are not, if the dampers are not properly working, you can reduce the required airflow as you require. Thereby, you can, at the end of this might happen, right? Airflow holes will happen, right? So maintenance of the withering trough is very important. Some leakage, right, should be avoided, the leakages, right? Right. Actually, this graph shows you the moisture removal rate of the green leaf, right? With time, you can see initially at the beginning the moisture removal rate is high, but with time it is happening smoothly, because with time latter stage the moisture content in the core inside the tea leaf, right? Because of that, the moisture removing rate is very slow, right? Actually, that nature, we use that nature of the operation, we use to reduce the energy consumption by employing the VFTs. In a VFT, because energy flow rate, air flow rate will reduce by controlling the frequency, right? Not by changing the dampers, right? Smoothly, you can change the air flow rate as you require, right? I will show you some withering, because we have done some trial tests, because I'm not going to discuss with you, right? This is how withering process, the effect of the result of reducing the VFTs, right? This is some real example what we did earlier. In this stuff, you can see the red line, right? Without VFT, and green line with VFT, right? So the actual, the calculated energy saving potential is 41, right? In graph 9, another one is 41%, right? And after implementation, we do the measure and verification process, and you can see this plot represent to the energy saving potential, because we have done this implementation in if I remember correct, 1,000 factories, right? Right. So another advantage here I have listed other advantages, not only the energy consumption, having a VFD, employee in VFD, there are a lot of advantages we can have, right? But unfortunately, people are not rely on this technology. Only limited number of industries still have gone for VFD application, right? This is how we can calculate the energy saving potential. Earlier, if we can adjust the pitch angle to get the required flow, definitely we can reduce the energy consumption. Actually, after adjustment, the power requirement is also reduced, right? It's a real actual example. This is a picture of the test rig, withering fan test rig at TRI, right? Then drying process. That is also another important area we have to look in, right? In drying, we use hot air to to remove the moisture, right? This is temperature graph because of the uneven dual feeding, because we have seen most of the places, right? Dual feeding is not even, right? Because of the, and this is the dust accumulation of the main inlet air to the main fan, because we know this area is dusty, so with the time the goes in the filter. So if you are not remove the dust, if you are not clean the filter regularly, there's a possibility of reducing air flow rate and thereby increase in the decrease in the energy utilization efficiency. So it is recommended to do the cleaning regularly, right? When it comes to the energy conservation opportunities in dryers, maintaining uniform thickness of dual, reduce air leakages, because sometimes we may found air leakages in the dryers, and maintaining correct temperatures is also very important, because if the temperature is not maintained correctly, sometimes you may have under fire and high fire conditions. Thereby, you can the quality will deteriorate, right? Right. And maintaining optimum air flow rate is also very important, right? And maintaining component efficiency. That's previously I discussed. The cleaning and maintenance of the drying accessories of the dryer is also very important, right? This is a picture of some uneven example of the uneven dual feeding, right? You can see, because most of the places we can see situation like this, right? So maintenance is also very important, because belt tightening is very important, because, right, you can see, because if you have a system like this, the power transmission efficiency will be decreased. You can see how will this kind of things will affect the power transmission efficiency, right? And some places we have seen some places, because some pulleys are running with lesser number of belts, because some belts are designed to use 3 belts, but unfortunately people are operating that pulleys using 2 belts, right? Those kind of situations are very common in the industry, but we have to avoid this situation, right? Misalignment problems is also another areas we have to look in, right? This is a good layout, factory layout, right? when come to the finally, when come to the renewable energy sources, right? Basically, sun is the sun energy is one of the key energy source we can use as a renewable energy. The sun gives two forms of energy: heat energy and light energy. Actually, heat energy we can use for thermal energy application. We can use it for generate steam. We can use it to heat up air and heat up water, right? And light energy, we can use reduce the generate the electricity. Actually, we have designed and uh, we have designed and Surya Bharat Sangramya to support this, and this program is nowadays operating very well. Right under this Surya Bharat Sangramya, you can install the solar PV system in your factory premises, in your rooftop. Not it's not allowed to install your solar PV system. Ground mounted systems are not allowed. Only you have to allow to install at the rooftop. Right, there are three schemes: net metering, net accounting, and net plus. In net metering system, there is no payment. Energy to energy will cancel. Right, if there is excess energy, you can carry forward. Right, if there is right in net metering system, it's like this. But when it comes to the net accounting system, if you have excess energy, you can get paid at the rate of 22 rupees per kilowatt hour for 7 hours. After that, from 8 years onward up to 20 years, you can get paid at the rate of 15.50. In a net plus scheme, it's a separate system with your existing power system. There is no connection with your excess system. You can install solar PV system on your rooftop. Then you can generate, the system will generate electricity, and you can export that electricity to the grid, and you can get paid at the prevailing existing tariff rate mentioned in this slide, right? This is the configuration diagram of net metering system. This is a configuration diagram of net accounting. This is a configuration diagram of net plus, right? Actually, to install, right, 1 kilowatt system, definitely nearly you need 10 square meters area. And generation, sometimes it slightly depend, but in general, you can generate 1 kilowatt hour system will generate 4 to 5 kilowatt hours per day, right? As I mentioned earlier, sun gives two forms of energy, light and the heat. If you can employ solar thermal technology, right, to meet your hot water requirement, right, easily you can reduce the electricity demand, right? Because we have seen most of in plantation sector, most of the bungalows, manager bungalows and other areas, people are using a lot of water geysers and online water heaters. Rather than using a geysers, online water heaters, if you can use this kind of solar water heaters, definitely you can reduce the energy consumption. Actually, this is a very good, very well established technology nowadays in Sri Lanka, right? When come to the when we talk about this technology, there are two kind of technologies: plate type and utility type. In plate type, actually, this system mainly most major part are constructed in copper, and but when come to the evacuated tube types, you may have system made out of stainless steel, that is food compatible stainless steel. So you can use the water from this evacuated type solar water heaters for the food application. So if you extended the piping to your kitchen, you can use hot water to your cooking application as well. You can use multiple use such like that, right? Right. But important thing is like solar panels, orientation, the installation is very important. because of the uh, because the solar panel, we should install the recommended tilt angle, right? Eight degrees, the direction to south, right? Like so, I convey this message to the client, right? Because they came to your place and they installed what they want, right? But if we know this correct orientation and correct direction, we can ask for, right? So be careful, because this is the correct orientation till degree, 8 degree, and direction south. If you can install the system like this, definitely you can get more, you can get, right? That's actually, this is a good solution, because especially nowadays most of the government factories, they employ solar water heaters together with existing boilers. Earlier they use electric boilers to to make tea, right? So nowadays they install rooftop, and this system normally it generate hot water in the range of 80 to 90 degrees. So then you need to elevate, only increase the 10 degrees using the grid electricity. Then drastically you can reduce the energy consumption. But if you have more energy hot water requirement, then you can consider this technology as a good technology, right? So actually, that's what I want to plan to discuss today. So Bandara, if you have any clarification, now I can answer.
Yes, we will give you a couple of times to the participants to raise the questions if there is any questions regarding the sessions. And I'd like to remind to all the participants, we will share the soft copies of these presentations that delivered today to your email, respective email address that you have given to us. We will share all the details and all the presentations with you. If you have any questions, you may ask now.
Actually, to find out the energy conservation opportunities, it is without conducting the energy audit, it is difficult, right? In the energy auditing process, what we do is we normally in energy auditing process, we explore your energy in and out and your system, and identify the energy. We first identify the energy, construct the energy balance. Then only we can identify, okay, this is your biggest energy consumer, this is the second one, this is third one, likewise we can first identify, then we can analyze your energy system. Thereby we can identify energy saving at what is the payback period, right? If you conduct the energy audit editing process in your premises, then only you can identify the energy conservation measures and potential areas, right? Later on, you can, depending on the budgetary allocation, you can plan out the implementation mechanism, right? But unfortunately, nowadays, most of the people, they are not rely on the energy efficiency, but because in my experience, actually, if you can maintain your energy, equipment efficient manner, definitely you can bring down the energy consumption by 10%, 20%, most places. But without investment, using no-cost measures by making aware the people, you can reduce energy consumption by nearly 5 to 10%, right? So when frequent awareness is also very important.
And Mr. Kisiri, there is another question in the chat box. What is the equation to measure kWh of a motor, e.g. 15 HP? As well as there is another question, how can we get the energy audit done?
Yeah, in first question, actually, for example, say to calculate the energy consumption of a given equipment. First, we need to know the wattage of wattage, right? For example, if my appliance is small, normally the manufacturers will mention the capacity in watt, right? If my equipment is large, the capacity is mentioned in kilowatt. First, you need to know the kilowatt, right? So okay, let's say we have a kilowatt, we know the kilowatt. Then the other parameter what we want is operating time. For example, at what time you start your motor, at what time you switch off your motor. Then the time you should take in hours, right? Not minute or other units, right? Then once you multiply the kilowatt into time hours, the answer will give you the energy consumption of that particular appliance or particular motor. It's simple, but the problem is if your load is varying, for example, because motor is not a problem, it run constant speed. But if you are employing VFT, right? Because of VFT, the frequency, the VFT, the energy consumption will vary, right? In that scenario, we can use this formula. But for the fixed load, to calculate the energy consumption of light, to calculate the energy consumption of the motor, to calculate the energy consumption of the pump, definitely we can use this formula, right? The second question is, because earlier we did energy audit as well as a sustainable energy authority, because nowadays actually with the limited number of staffs and we engage a lot of national level energy efficiency programs. So to cater the demand, because instead of us, we have registered energy services companies with SEA, right? You can get the service of the energy audit services companies to get done the energy audit at your places, right? So you have my email address. If you have such kind of requirement, please drop me an email, or I mentioned my phone number as well. If you have any questions, you are welcome anytime, right? We are happy to help you, because now earlier I look after all energy management side. Nowadays I am mainly focused on the industrial side. So definitely I will help you. Okay.
Okay, thank you very much, Mr. Kisiri, for your brief answer for these two questions, as well as throughout all the lectures. That the things you delivered with the participants about the topic. So I would like to thank you again for your kind participation for these programs to get the success and to get the maximum benefit from the program. So now we are at the end of the programs. We had 3 consecutive lectures today. We didn't have a tea time because we need to finish this quickly. So I'm like to cordially invite Ms. Nishamani Ilangantilaka. She's the head of academic affairs of the National Institute of Plantation Management. This is the time for the vote of thanks. Over to you, Mr.
Yeah, good afternoon, everyone. Now we have come to the end of this workshop on energy management and conservation. Actually, being the professional body of this plantation industry, NIPM time to time organize and conduct this type of workshop. This workshop also a result of this our effort. Actually, I think this is a very valuable and timely, very valuable workshop. I hope all of you could able to gain new knowledge and also many important information regarding energy management and conservation. And also hope you will be able to use this new knowledge and information at your workplace when you are implementing your work. And now, finally, I will take this opportunity to thank all the resource persons who have dedicated their time to share their experience and knowledge with us all. Engineer Harsha Vikramasinghe, he has delivered a lecture on energy policy, codes and standards. And Dr. Tilak Siambalapitiya, he has delivered energy information management, monitoring and evaluation lecture. Then Engineer Sanat Kitsiri, energy saving opportunities and practical ways of energy conservation. So I am thankful to all the lecturers, all the resource persons on behalf of NIPM. And actually, in this moment, I also would like to thank our director, CEO, Dr. Prasad Dharmasena, who is always guiding us to conduct this type of workshops. Finally, I thank you all for your active participation for this workshop, and wish you all the best and stay safe. Thank you.
Thank you very much, Mr. Shama Ilangathanaka. So we are at the end of the our workshop. So I would like to say thank you very much for your kind participation for this wonderful workshop. I hope that you get the maximum out of from today from your participations. And even in this pandemic situation, we will have to move forward as a nations. So that's why we are bringing this new workshop to you, the online version. This might be quite new to the all of the participants and to focusing on your attention throughout to this screen. But anyhow, we will have to move forward, bring in more varieties. That's how we are going to develop as a nation. So thank you very much for your kind participation, for your 3 hours times. I hope that you might be get the maximum from this workshop. And thank you very much for once again for your participation. Good luck for your future as well as for your future endeavors. Stay safe. Thank you very much.
Thank you. Thank you very much.